Hallo, Test, Test. Hallo, Test. Okay. James? I'm good, how are you? So I already asked a couple of questions in the chat, and more people have replied than the. Oh yeah, yeah, okay, sorry. So no, no. I've asked some questions in the chat, and a bunch of people have answered, but they're not here in the Discord stream. So maybe they'll join in a minute or so. Seems like 15 people at the moment. For the people that are already here, I guess that you've already seen my messages on top of the chat. There is one more question which no one yet answered. Don't feel obliged to do it, but it could be interesting. The question is, why are you following the workshop, and is there any specific, anything specific that you would like to know after today? And why am I asking it? Basically because this might give me the opportunity to relate to specific use cases while we go through the course materials. And for you, maybe it's interesting to then have a specific idea as to how you might need to get started using Git and GitHub after today's workshop. So many more people joining. Good morning, everyone. Ah, I also need good morning, everyone. I completely forgot to share my screen here in Discord as well. Voila, now that's done. It's 30, it's almost time to get started. And I will also share my video here. Let's see how, it's not going to work because it's occupied in OBS, of course. Yeah. Uh-huh. A couple of people is now only one anymore, and the person is gone. Okay. Good morning, everyone, again. I will still wait one more minute before we get started, in the hope that more people will still join. You can follow my stream in Discord by clicking next to my name on the live button and then join stream. Or you could go to the YouTube link, which is given in the course chat, and there also the same content will be streamed, of course. The YouTube stream has 15 seconds delay, so it's a bit slower, but sometimes the Discord is causing problems for some people. So this is why we also stream on YouTube. All right. Hiria. We know your situation in in the meanwhile. Okay, so let's get started, and maybe I will start with saying something about Discord before we really get started. In the chat, and let me pull my Discord here in the stream as well. In the chat, if you scroll all the way up, I've added the slides for today, so you can download the slides. And what did I not do? What I still needed to do is also give you a link to the course materials. But I will come back to that actually later on. But I already pasted it in here in the chat as well. So the slides are in the chat on top if you scroll all the way up. And then I've asked a couple of questions. So if people still join now, have a look at them, fill them in while we go over the introduction. And then one more additional question, which is maybe a bit unrecognizable. It's like not really clear that it's there. The question is, why are you following this workshop? And is there anything specific that you would like to know after today? Not that you have to answer it, but it might be interesting for us to know why you are here, because then we can relate to the example that you give as an answer to this question. And yeah, for you, it might be interesting while we go through the course materials and I'm relating to your example, then you already have an exact answer to your question. So it might be interesting for you as well. It will be mainly me giving the workshop today, which means that it's difficult for me to keep an eye on the chat. If it's possible, feel free. We're not that many people, so feel free to just jump in and ask your questions speaking out loud. What you have to do for that is to set your microphone properly. James will keep an eye in the chat, but maybe at some points he won't be here. But usually James sticks around, keeps an eye on the chat, and then answers the questions that you might have already in the chat as well. So if you want to set your microphone, let's say properly, there is also a link, and that's given here. Oops, this link. And if it doesn't work, just type it in the chat. James can help you right now. And otherwise, I'll see it when you want to ask something, maybe a bit later, but then I'll still answer later on. So that's it for Discord. Let's see, what else did I type? That's it. I will go over the answers here later. First slide, introduction to Git and GitHub. So that's what today's workshop is all about. My name is Tuur. I'll be teaching the materials today. Teaching is a great word. I'll be explaining everything today. I'm a bioinformatics trainer at the VIB Bioinformatics Core, and I'm also active in the Elixir Belgium project. James, my colleague, is a software developer, also tons of experience with Git and GitHub. He'll be here, as I mentioned, to keep an eye on the chat, to answer your questions there. Maybe also notify me if something is wrong, like if the stream is not working anymore or something like that. So that's a very basic introduction of ourselves. What are the objectives for today? As mentioned actually in the training, on the training website where you registered, it's understanding how Git and GitHub works. So it goes into the basic concepts of Git and GitHub, so of version controlling, and start building up from there. We will create a repository ourselves and use this repository throughout the whole course. And keep building on this example. So if at any point it's not clear anymore for you what's happening, I don't hear it properly in Discord. Okay, so but it's clear in YouTube, so that's good then, I guess. So if at any point you're not really following anymore, please do mention it, because it's best that we clear it out as soon as possible rather than having worse problems later on. Version controlling is 90 to 95% using the routine usage, and hence this is what we will stress the most throughout the course. But of course, it's more than this. If we have a full day talking about version controlling, we will also definitely take the time to elaborate on many other aspects of Git and GitHub, such as how we can make branches, how we can merge them, and what would be our strategy to collaborate on projects and repositories. And if nothing of this is clear, then of course understanding what I'm saying right now is also an objective for today. The audio from Discord is bad. I have to select a different microphone. I will do that right now. Of course, input device. So now this. Yes, yeah. I thought so. Okay, so this should do the trick for Discord. If you're following on YouTube, you prefer Discord, you can still switch now. And I have to close this. Okay. So far the objectives. I've drafted a schedule, not that I will stick to it, but at least it should give you a decent idea of what's laying in front of us. We'll talk a bit about why we use Git and GitHub, as well as how to set the configurations. That's a first-time effort. Then afterwards, we will elaborately discuss the routine usage of version control systems, so Git. And then we will also talk about the history and status, how we can make branches, merging them, collaborating, as I mentioned before. Very shortly, also mention gitignore files. And then we should still have enough time to discuss things that are interesting for you, for example. So let's say, are you working in Rstudio? I can show you how Git is working on Rstudio. Do you have a specific goal in mind? So is your lab using GitHub and you don't know how you need to work in that philosophy of your lab? Then we can talk about this at the end of the course. So once again, if you have any questions, type them in the chat in Discord. I will not keep an eye on the chat of YouTube, so it's better to keep to ask them in Discord. Feel free to speak out loud, so then I'm sure that I've heard and seen the question, and then I can also answer them for everyone. James will probably also mention if there is a question that is relevant for everyone, he will mention it to me, and then I can reply to everyone. There will be exercises. As I said, we will work together on this project and we will use it throughout the whole course. So I will type in the Discord chat something like exercise, and then it's up to you to either thumbs up or thumbs down if it's going well, or if you're finished, or if it's causing you headaches. And then we know we can help you specifically, or we can give some tips to everyone maybe. Then of course I will ask for feedback at the end for future editions of this course. Also mentioned before, the slides are the materials for today, but actually the slides are a distillation of all of the materials that are present on our website. So I've also already copy-pasted the link in the chat. So this is where maybe later on next week, if something was unclear or you want to have a look at something again, you can go to the website and have a look over there. And of course, we're always open for any questions later on. So if you want to contact us, maybe James will write our email addresses now in the chat, and then you can always contact us if you have any questions later on. And the repositories that we might use later on, yeah, we'll see about that. I've asked you to do some installations before the course. I hope this worked out. If it didn't work out, you still have time, of course, to do it now, but it's important that you do it actually. So Git is the most important installation. The link is over here if you haven't done it before. You'll also need an account on GitHub, also very important. And then less important is the end, where we will do one exercise with Rstudio. So for the people that use Rstudio, they can just follow along. If you do not have it installed, it's also not that bad, actually. And then I've read the description on the training website, and I mentioned that we might use GitHub Desktop. We decided not to do that, and there is this very specific reason for this. We want this course to give you an overview of how version controlling works. So all of the principles, all of the concepts, we want you to know how it works, like in the core of Git. And GitHub Desktop, as well as Rstudio, as well as Visual Studio Code, they all offer ways as to how we can use Git in another program. So they integrate how Git works in this program, in this software. And hence, I mean, it's just another variation on the topic. It's more important that we grasp how it works rather than how it works on a specific program. If you're interested in using GitHub Desktop, after this course, you will be able to see a tutorial of 10 minutes and understand perfectly, or that's the aim at least, perfectly what's it talking about. And that's the last slide as to the general introduction. Now I will have a look at the questions that I asked in the chat, where I was interested in knowing what your experience with Git and GitHub is so far. And this I'm asking because I want to have an idea of where everyone is at this moment, and this course is also good for everyone here, and it seems like this is the case. So it's really a basic course. We will elaborate on all of the different concepts. So if you're not really used, or if you don't know how it really works, Git and GitHub, then this course is perfect for you. I'm also happy to see that most of you have used the command line at least a couple of times, except for this one person apparently. In the slides, you will always find almost the exact commands that you need to do on the command line. So it's not going to be rocket science, or it's not supposed to be rocket science. I don't want this to be like the thing that holds the learning process back, but I think it's important that we look how Git works on the command line, and I will come back to this aspect. And then why are we following the workshop? I will read the answers during the break, and then I will come back to that throughout the course. If there are no questions at this point, I will start with the first chapter, let's say. I'm just waiting a second in case someone is still typing something. Also, feel free to send me a private message. This is possible in Discord. send me or James a private message if I'm going too slow, if I'm going too fast, and you don't want to mention it here to everyone. So don't feel shy. To tell me if I'm going too slow or too fast. Also, we'll not use VI, James. So if you're not used to command line, it's still possible. I will explain how to omit all of these very specific command line things. All right, let's get started with a more specific introduction to Git and GitHub. Some basic reasons as to why should we care about version controlling, and then also already explain the conceptual areas that are there in Git. And now I'm going to close one and the other, so it makes sense for me. Okay, so Git and GitHub are technologies that you can use for what's called version controlling. And basically this means keeping track of different versions of your project. And it's important to stress the difference between Git and GitHub at this stage already, where Git is an open source command line tool that works really on your computer. GitHub is an online hosting platform for storing these repositories. Okay, so Git works on your computer, and GitHub is actually just a website where you can store the repositories and share them with the world, for example. So there is a difference between Git and GitHub. And there are also alternatives as when it comes to GitHub. We've chosen now GitHub because it's we could argue about this, but it's I think by far the most popular version controlling sharing platform that there is. But alternatives are GitLab and Bitbucket, for example, and your lab might use GitLab or Bitbucket as opposed to GitHub, or you might at least have heard about it before. But in this workshop, we will just focus on GitHub. If you're interested in some more background knowledge as to version controlling systems, we might maybe also discuss this at the end of the workshop. It's not really important at this stage, but Git is also not the only one in the field. There are other possibilities as well, or there's one major possibility as well. But let's not focus on that. So why do we want to version control? And one of the reasons, or one of the main reasons at least, is keeping track of changes to your code. And this is basically where version controls are made for. So imagine that you create a file and you add a line to it, and then you remove it. In this Git philosophy, you can always know exactly when you did which changes. Whereas if you're just working on a project on your computer without it being version controlled, you'll make changes and you will not be able to have an overview of when did you do what changes. So this is what Git can offer you. And this is a very important reason as to why we're interested in using Git. Another great example is synchronizing code between different people. And let's have a look at this example where, for example, on the left-hand side, you see my computer, and on the right-hand side, you see James's computer. And we're both working on the same project. And the project is actually also present on a server, for example. Then we could say we're on the same day working on this project, and I'm adding a line over here, a equals to 1, and James is adding the line d is equal to 4. At the same, well, not exactly, but at the same moment we can push these changes to the same server. The server will accept it. So this shared repository will accept them. And then from that point, we can merge these changes back in. And then we're back again working on the same project. So this is a very nice way to work on our own project, on the same project in our own way, and still keep the synchronization between the different versions. Synchronize the same project. Sorry. Testing new codes is also a great example. So what Git allows you to do is make what's called a branch, which is basically a copy of this project. And then in this copy, you can do whatever changes that you want to do. And then later on, you can merge these changes back into the original project. So what would you do on your computer normally? It's make literally a copy and then my voice, wow. And then make some changes in that copy, and then there is not really a way as to how you can synchronize these two files together again. And Git is able to do this for you. So that's a very nice feature, and we will also mention this, of course. It will be part of the workshop, of course. And then reverting changes is one last example that I will mention here. Let's imagine that we start with this file and that we do, today we're doing this first change. We add the B parameter here, and then tomorrow we're doing this D parameter change. Then next week we can have a look at this script again and then say, you know what I did today, adding this B line, it's not good after all. I can just revert these changes, which means I'm going to pull them out and throw them away. And now you can look at this and say, well, yeah, obviously I can just go to the script itself and just remove that line. True, but imagine that your program is like 1,000 lines big, and in order to add a new feature, for example, these changes are present on the 1st, on the 5th, on the 105th, I don't know, on many lines, then it might be error prone if you're trying to manually delete all of the lines that are related to those changes. So if you structure your work properly in Git, you're able to just say all of the changes that are related to each other, we can just throw them away. And that brings us to explaining the conceptual areas that exist when we talk about Git. So no questions in the chat so far. So this is one of the most difficult things to explain. I think the most difficult thing to explain in any kind of workshop. Because it's difficult to grasp, like, in your head. So Git works on your computer, right? I've mentioned that before. Imagine that you have a folder on your computer, and this folder has multiple files. This is, if Git is working on this folder, then this is what we call the development area. Okay, so a project or a repository, if I refer to a repository, is a folder on your computer that consists of one or multiple files. And any changes that you do over there, I mean, this is where you work on the code really. Okay, sorry, that was bad explained. This is where we work on the code, and this is hence why we call it the development area. Once Git is initialized on this project, Git is going to suggest you. So basically, in this development area, I'm sorry, in this development area, Git is not going to do anything. All right, it's not going to change anything on this project. It's not going to do anything. But once Git is initialized, Git is going to explain to you if there are any changes. It's going to tell you there are some changes. Do you want to save them? And in order to save changes, you need to do two different things. You have to add them to a staging area, and then you can commit them to the commits repository. Okay, so there are three conceptual areas: the development area where you're working in, the staging area, which is only like the staging area, and the commits repository, which are part of the Git logic. So the staging area is an intermediate stage which assembles all of the files with changes that you want to save. Okay, so imagine that you've changed the file here in the development area. You want to save it. First, you will have to add it to the staging area. And from this point, you can say all of the files that are in the staging area, we can commit them. And committing is basically, it means saving them. At this point, everything what we've done was happening on our computer locally. Okay, Git works on our computer locally. However, if we want our projects, our repositories to be visible on GitHub as well, then we need one more step, and that is to push them to the GitHub repository. So once initialized a project on our computer, Git is keeping track of changes to this project. If it sees any changes, it's going to tell us there are some changes. Do you want to add them to the staging area? We can say git add them to the staging area. Then from that point, we can commit them to the commits repository. You can think of this as basically Git is going to take a screenshot of your file, and then in another change, if you go back, you make some new changes, you add them to the staging area, you commit them, Git is going to take another screenshot of your changes. And then this is called a repository because it's just going to give you a list of all of these screenshots of all of these different saved changes versions. And then at any point, we can push all of these changes to the GitHub repository, and there it will be then visible on GitHub for you privately or for everyone. Don't worry if you don't really understand what I'm saying right now. I will show you in a second how it works in practice. When we start using Git for the first time, what we need to do is add some configurations. So change some of the configuration parameters. It's the same as you download any kind of software and first you need to log in, you make an account or something like that. This is also necessary on Git. So we will do that in a second, but just as some background information, there are 3 levels of configurations. The first level is the lowest level, and this is on an individual repository. So you can have configurations that work on a specific project. You can have configurations that are working on a user level, which refer to the global parameter. We will come back to this. So on the user level, this works then for your computer, for you, for you personally. And then you have a system settings which work on the whole computer or the whole infrastructure. But we will only focus on this user level. So these are the global settings then. And at this point, I would like to ask you for the Windows people to start git bash, and for the Mac or Linux users start the terminal. And if all goes well, for the Windows users, it should look like this. Okay, so it's a file, it's a program that looks like this. And then, let's see, I can't copy paste, of course, here. I'm going to copy paste the code that you should enter. Need this. Okay, we're there. So in the Discord chat, James has James has already put it in. So in the terminal, we're going to type git config global and then list. And then what we're getting back is a list of parameters, that configurations that are applicable for me. And yours will look a bit more like the one that James has put in the chat. The essentials that you... maybe it's even empty. Oh, putain, we had the same problems last time. The first thing that we need to do is to create this config file. It's a one-time effort, so I don't know the command by heart. Let's git create config file. But if we do the first commands, it will create it by itself. Okay. Maybe it's not present for you, but it will then be very soon. So what we need to tell Git is basically who we are and what our email addresses are. And these need to be the same as the ones that you're using for GitHub. So this is very important because later on, this configuration will communicate with GitHub, and it needs to recognize the same username and email address for it to be sure that it's working properly. So what you need to do is git config. So this means we're going to do something with the configuration file, and then type global as to, this relates to, we're going to use the global level. So for us personally, and then we need to state username, and then in parentheses, quotation marks, write our username. So mine is tmelder. And then the second thing that we need to do is git config on the global level, and then type our email addresses, which for me is my personal email address, gmail.com. Okay. And now let's see if we do git config global and then list, if you have a configuration file present right now. And normally it should contain these two lines now, the username and the user email. And I'm watching the chat to see whether it worked out for you. You indeed need to set both username and user email. I'm sorry for the confusion. It's really, you only need to do it once in the beginning, and then and then you forget about it. So yeah, even for me, I do forget about it. Now, I presume that it's working for everyone. If it's not, let me know. I will just quickly explain that for me there are other things present here, like aliases. I will explain that right before lunch what it is. Also, a core editor is present. And I'm going to go to the next slide because that talks about the core editor. So during the workshop, well, during the routine usage of Git, Git will ask you to sometimes write a message. And if you forget about this, or at any point if something is going wrong, there are conflicts, Git is going to ask you to solve these conflicts. And for this purpose, it needs an editor, which means it needs a program that can do some textual changes. And there are many possibilities, like if you're a hardcore command line user, you might use Vim or Emacs. Windows user might use Notepad, but also other programs like Visual Studio Code or Atom are also possible. So if you want to set this, I don't know what the default editor is, but you can change it by using this line, git, and I'll also type that in the chat, git config global core.editor, and then the name of the editor. And you can see, if you look at my configuration file, that my core editor is Atom. So if something goes wrong and I need to give some textual inputs to Git, then it's going to launch Atom as a program. And then I can do some changes over there. Yes, why do I mention it? Because James rightfully points out that you do not have to do this. James is a hardcore software developer. He uses Emacs. If you're not used to using Emacs, if you don't know what it is, don't start with it now. Why do I mention it? If your default is VI or VIM, so Vim, and you don't know how it works, and something goes wrong during the workshop, then you might get stuck, because it's a bit confusing if you use it for the first time. So maybe Windows users can use Notepad, or I think even Word would be an option, but let's not use Word. Don't use it. No. All right. I'm just saying, theoretically, maybe it's possible, but it's, like James said, it's a no-go. Yes. Someone is typing, maybe there's a question. So apparently during the installation process, Git in Windows might have asked you to choose the editor already. Oh. Can you say something again? It's not working. I'm going to fix it. Thanks for mentioning that. Properties, default. Can you say something again? No. We're having technical issues here. Solving them right away. Can you say something again? James? No.
Testing.
Yeah, now we're there.
Great, cool.
Okay, so what James just mentioned is don't use Word. Rightfully, it's not supposed to be the editor. So I'm not sure what the question is are the configurations already set when I installed Git in the Windows system? Are you using Windows Terminal? I'm not sure if I'm not sure how it works over there. But at any point you can still then, if you would have used it, used something during the installation, you can still change them later on. Okay. Last thing that I'd like to mention regarding configurations is that it's also possible to connect to remote servers and services in a secure way by means of an SSH key. This is something which you can set maybe after the course. It would just drag us too far to from what's really important here during the course. The instructions are listed in this link. It could or would make sense that you set it at some point, but it's not necessary to for this workshop at least. It's not really necessary in the beginning. And then aliases, as I mentioned, we can elaborate on it later on. Basically what it is, you can make your own Git command. And this is possible by means of this alias. And that's all what I'm going to say right now. But this is also part of the configurations, and you can change them in the configuration file. And that brings us to the first commit. We only started 9:30, so I think we can start explaining a bit about this. There's a lot going on. There's the YouTube stream, the OBS that streams to YouTube. There's the course chat in Discord. So I'm keeping an eye on a lot of programs here. My apologies if sometimes it takes a second before we go on. All right, so the next chapter is called first commit, because committing is what lies in the core of using version controlled systems, in this case Git. So what this chapter is all about is the routine usage. And I will start by explaining in words what is going on and how we can initialize a repository. So that will be the first part. And then I'll show you, or we will work together and create a repository on GitHub, and then work from that point on in our own projects, in this project at least. We will make our first commit together. We will learn how we can pull changes from GitHub into our computers, and then also how we can create a repository on our computer and then link that to GitHub. At that point, you'll probably be asking, why does the staging area exist? This will be the last part of this chapter, but that's for later on. So first, let me explain the routine usage again and how to initialize a repository before we get started with some practical examples. So as I mentioned before, there are three conceptual areas in Git: the development area, the staging area, and the commit repository. And the routine usage is depicted here in this slide. And when we want to save a file from the development area on our computer, we'll always have to add it to the staging area first. So that's what the first line is doing here. Imagine that you changed file A, for example. What you would write on the command line is git add file A. Let's say that it's a text file, so .txt, git add file A.txt. And then this file and all of its changes is present in the staging area. From that point, we can say committed. So this literally means save the changes of this file. And that's what we do with the next line. Git commit -m and then some message. So imagine that you would not add this parameter -m and this text. What Git will do is fire up this core editor that we specified in the configuration file, and it will ask you to write a message in that core editor. So that's a bit of a lengthy process. What you usually do is git commit -m to tell Git already at this stage, we're going to give it this message. So let's say that in file A, we did a change, for example, the title. We added a title. Then we could say git add file a.txt and then say git commit -m. And then as a text, we tell something about what has changed. So in this case, it would be changed the title, for example. And then Git has this version of this file saved in this commits repository. From this point, it's possible to push it to GitHub, which means we're going to publish these changes on GitHub. And this is the routine usage. Let me show you that command, git push. There are many other parameters possible here, but this is 90%, 95% arguably of what version controlling is all about. This is the routine usage, and this is what we will use all the time. Add, commit, push. Now, before Git is telling us there are some changes in one of these files, and before we can save them to a commits repository or push them to GitHub, what do we need to do? Of course, is initialize a repository with Git. So this is the first step when you start a project, or maybe you already have a project. You can also initialize Git at this point on that project. Okay, so there are two options when it comes to starting a project that is version controlled. The first option is that you start on GitHub, and you can create a repository on GitHub online, and then clone it, which is a synonym in the Git terminology for downloading. So clone it, downloading it into our computer, and then on our computer we can start working on that project. And then the two of them are linked together because we downloaded that repository on GitHub into our computer, but also all of its history. So imagine that it's a project from a colleague and you're cloning it into your computer. It also contains the history of that project. And second option is that you initialize Git on a folder on your computer. And this could be an example of, imagine that you already have a project and now you want to start using version controlling. This is when you would go for option 2. And yeah, you can already ignore when option 1 and when option 2 because I already explained it. But reason about this, why option 1 and why option 2. So initializing Git on a folder on our computer, imagine that it doesn't have a repository on GitHub yet. You still need to create a GitHub repository, and you will need to create an empty one. We will come back to this, but it needs to be empty, and then you can connect your local folder with GitHub. So this is the theory. I hope at this point already it makes kind of sense. If not, I will start with explaining a bit the GitHub platform, like really the basics, and then we can together create a repository on GitHub. So at this point, I'd like to ask you to open GitHub. Or just look at my screen, then at least you can see how it looks for me. So whenever you open GitHub, this would be the first page, the landing page. And it's divided into 3 sections. And on the left-hand side, you can see, if this is the first time using GitHub, probably it only contains your profile name here. But imagine that you're also part of a team. This could be your lab team. It is listed here as well. So imagine, so for me, I'm active in the bioinformatics core VIB bits team. This is one possibility to change. I can switch to this account as well. And then the repositories that I've currently been working on are the following. They are listed over there. And you can see that they contain of 2 parts. It either starts, in my case, with my account name, followed by the name of the repository, or it starts with the name of the team that I'm working in, followed by the name of the repository. So this gives us an idea who is the owner of the repository. And then there's 2 more options that you see here. Either it has a lock or it's a book icon. This represents either it's closed, it's a private repository, or it's an open repository. So you can see that I'm keeping my presentations locked, so it's only visible for me. The ones with the book are visible to everyone that's active in GitHub. You can see that there are a bunch of them. And then in the middle section, you can see something which looks like the Facebook wall, you could say. So you can follow people. I'm following, for example, this Tanya Allard, and I'm following the Silver Viking. Any changes that they do, which are also which are public, they will be visible here on my wall. I'm not really active in this way, but software developers sometimes can track like a program code or projects. You can follow them, and they will, any changes that happen on them will appear here. Right-hand sides are some examples that might be of interest to you. The navigation bar is something which we will discuss later. What's important, well, and on the right top-hand side, you have a notification alarm, which also lists all of the things that are relevant for me. Not really important at this stage. This is maybe an interesting one, the plus sign on the top right corner. It contains the options new repository, import repository, new gist, new organization, or new project. So this is where we can create a repository, we can create an organization, just like VIB Bits is one, and where we can create a project, which is still actually a different thing. We will only talk about repositories during this workshop though. So in the GitHub terminology, there is still a different connotation to projects. But when I talk about projects, I always mean the repository, right? Okay, so that being stated. And then, your profile settings. If I would click on mine, you can see a bunch of irrelevant things like popular repositories, how active I am, and contributions that I've did publicly lately, people that follow me, organizations that I'm part of, etc. Okay, so that's GitHub so far. And I'm going to have a look at the chat again. Give. GIF. GIF. Okay, James. As long as you're having fun yourself. So at this point, I would like to propose that we make a repository together. And as I mentioned, there are two possibilities to do it, either on the upper right corner, clicking on the plus and selecting new repository, or clicking on the green new button. So let's do that. And then a new page will pop up that looks like this. And here we're going to set the essential information of the repository that we're creating. For example, I'm going to call mine introduction GitHub. It already exists. So let me call it December. The key is to not make it too long. You could argue that this is already quite long, but anyway. Some description is always interesting. Repository for the workshop introduction, Git and GitHub on 10 December 2020. If that is set, there are two options. As I mentioned before, you can either make your repository public so everyone can see it, or you can make it private so it's only visible for you. I will make it public in this case. It doesn't really make sense if you do it, so you can keep it private if you like. There's just a couple of things that you need to think about, at least when you go public, or the most important thing, at least when you go public, is the third option here listed, is choose a license. Why is it important? Imagine that you're the owner of this project, which contains like very valuable algorithms analysis. You might want to share it with the whole world, but you want to be acknowledged for it. So you need to add a license to the repository and then say, everyone can use it openly, freely, whatever it is, but you can even change it. But I want you to recognize my work by referring, like, citing me. So that's why license could be necessary. A git ignore file is what we'll explain near the end of the workshop, why this could be interesting. Basically, GitHub is not made for storing your data. So what we will try to do is, if the data is present in your project, we can add some descriptions in this git ignore file, which will then tell Git and GitHub that the data files will not be included in the repository that is pushed to GitHub. Okay, so we can have then the data files present on our computer in the same project, but they will not be present in GitHub. That's the idea of the git ignore file. And then a README file is an important thing. At least it is important because it will generally contain information about the project, about the repository. For example, some basic explanation of why it's there, the authors of the project, how you can refer to this work, how you have to use it, how you, these kind of stuff. That's generally what's written in a README file. Maybe how to download it, how to use it, yeah. So the next thing is to create a repository. And in this case, so I'm doing it publicly and with a README file, and that's it. Okay. And then a new window will pop up, which is how a repository on GitHub looks like. And I'm just quickly going to my slides to see that I'm saying the right stuff on the right time. Okay, so maybe very shortly here, what do you see? The icon that it's publicly available for everyone. It's part of my account, this repository, and this is the name. The description that we added is visible here on the right-hand side. And you can see that there is a link to the README file. Here, in the middle section, let's say, is a list of all of the files that are present in this repository. In this case, we only have one file, which is the readme.md file. And by default, if there is a README file present, GitHub is going to visualize that file underneath the list of all of the files and folders that are part of this project. Okay, so this is why we see here readme.md and then a title, Introduction GitHub December, with some description. So at this point, I will come back to all of the features that you're seeing here. But at this point, what's important to see, we have the list with all of the files and folders here, and the README file is described underneath it. You can already change this file by clicking on this pencil icon. We can, at this stage, already add files, so we can upload a file here or create a new file on GitHub as well. And yeah, this is basically it, what I wanted to show you so far. So while you follow along, I'm asking you to follow along now. While you follow along, if something is not working, let us know. The question in the chat is, can you delete it? Of course you can delete it. If you would want to delete it, you would have to go to settings, and then in the options tab, just scroll all the way down. And then there is this option to delete this repository. So at this end of the workshop, you can immediately delete it. So I hope you've created this first repository as well. And if that worked out fine, this allows us now to clone the repository from GitHub on our computer. What does it mean? What's going to happen? We're going to download the project, the repository from GitHub on our computer. It will create a folder that contains all of the contents of this repository, and then we're able to start using this repository locally. What do we need to do for this? Is click on this clone button and then copy the link that is given over there. And then we're going to switch to the terminal or the git bash, and then we're going to write git clone, and then we're going to copy paste the link. So how does it work? For me, copy paste. So I'm clicking on code, copy paste, so Control C, and then I'm going to the terminal. Let me clear all of these irrelevant things now. And what I'm going to write is git clone, and then Control V doesn't work on git bash, so I using right click and then paste, and that does work. So the link that we copy paste is not the link of, it's not identical, at least. It looks very similar. It actually just has a .git extension, which means it's this link, but it's a Git project, let's say. Okay, so hit enter, and then, yeah. Git has then cloned it on our computer, but maybe we need to set a location first. So right now, I'm in my home folder apparently, which means that I am, let me show you. See users to. So now I am in this folder. This is why there's so many files present. Let's say that I want to store this folder in my documents folder. So here, I double click it. I want it to be part of this list of folders. So I want it to appear here. What I do here in the Git terminal is cd, which represents change directory, and then the name of the folder that we want to go to. So in this case, it's documents. So if I list all of the files with ll here, you can see that now we're in this folder that has all of these subfolders. So if I want to download the GitHub repository here, now what I do is git clone, right click, paste. I lost the link. Control C, go to Git terminal, right click and then paste, and then hit enter. And what's happened now is there is one more folder which is called Introduction GitHub December. If I open it, you can see that it contains this README file. I'm going to change directory into this repository. So cd and then Introduction GitHub December. If I list all of the files that are present here, you can see that the README file is present. How do we know now that Git is working on this folder, right? So there is nothing really that tells us at this point from which we can like relate or from which we can derive that Git is working on this project. How do we know it? If I would type ll-a, you can see that there is a .git folder, and a dot in front of a folder means that it's a hidden file. It's a hidden folder in this case, which means by default, and at least in Windows, we're not able to see that this folder is there, but it is present. So if I, instead of using ll, now use ll-a, we can see that there is a Git folder, and this is an indication for us that Git is working on this project. Or on this folder, as you like. Another indication in this case, but I'm not sure how it will look like for you. For me, it's also saying this main, how can I call it, parameter. This basically means, this is also part of the Git logic. We will later on explain what it refers to, but at least you could know now that if this appears at the end of your description here, of this first line, that that it's part of that this project is a GitHub project. So if I'm changing directory one level back, you can see that it's not present. This means that this project is not version controlled. Let's change directory into another folder that I have, Nextflow course, for example. You can see that now it contains this master parameter. I know now here that it's also Git version controlled. It's empty apparently. And in it's because it's a folder. Yeah, okay. Okay, so far so good. I'm going to check the slides and see if this is an appropriate time for having a break and maybe already answer questions. Just going to change directory back into our repository, which is called Introduction GitHub December. And we're there, okay. Let's have a look at the slides again. So what did we do? We created repository on GitHub, we cloned it into our computer, and now we're all set and good to go, hopefully, to start working on this repository. And that's what we will do after the break, probably. Maybe there are some small things. Yeah, we will do that after the break. Oh! Yeah, so after the break, there is an exercise. Always checking. Let's see if there are questions. Thumbs up when you've cloned your new repo, thumbs down or PM if you're lost. So don't start doing this exercise yet. We will do it after the break, if that's okay. Do you know the ll-a command for Mac terminal? Is it possible that just ll gives you an all overview? I can follow the presentation and practice at the same time.
So LL is an alias that Tu has set up. What you're looking for is ls space minus L.
Let me know by private message if it's going too slow, if I can speed up, or if I'm not going too fast. Let's have a break and be back at 11 a.m.
Stu, are you there? Do you reckon they reuse the repository they've already created?
Yeah. I'm hoping that no one is starting with this exercise. So it's 11. We can continue.
Well, they don't have access to the file you want, right?
They don't?
Well, they can't click on the link that's there.
But they have the
We'll have to put
slides.
that. Oh, do they? Okay.
They have the slides, but we will put a link here maybe as well. Um, we're getting started in a second. Hier, waar was het? Okay. So the idea was, hello again, hope you had a nice break. The idea was that I showed you how to create a repository and then you would do it yourself as an exercise. However, I've already asked you to follow along, so you already have this repository. The idea is now that we change this exercise a bit and we work with this repository on. So from this repository on. And the idea is that we download this file, and I've entered the link in the chat. We download the file and we upload it directly on GitHub. And once it's there, we're going to, as it's a new change that happened on GitHub, we do not need to clone it anymore to our computer because it already exists on our computer, but we need to pull it. And that's actually something that I wanted to explain later on, but we'll have to do it here already because I messed up a bit. But maybe it makes sense that we do this exercise together. It's not that difficult anyway. So the link is in the chat. If you click it, I think it should download it normally. It contains a script that makes a plot in R. But it's also not that important what's written in there. It's just that we have a file. So if we are on our GitHub repository, what can we do to upload a file? Right next to the green code button is add file, and there we can upload files. Then we can either drag the files right up to this point, or we can choose files by clicking on that link. Let's say that I've downloaded this file and it's now in my downloads folder. It's called plot1. I can drag it in GitHub. And then GitHub is going to tell us that there is now this plot1.r file. If that's working out, we need to add a commit message. So that's that -m message if we say git commit. And what should we call it? We already have a suggestion. I'll say added file plot1.r. The rest of the options we leave as default, and then we say commit changes. If that worked out, put a thumbs up. If it didn't work out, you can do a thumbs down. For the people that are already done, you can go back to the git bash or the terminal. And if you are already in the folder that we just created, so if you are already in the repository, what we're going to do is git pull. And that's it. And I'm going to write in the chat git pull worked. And if that worked, we're back at the stage where we wanted to be. And then I'd like to ask you to think about these questions. And maybe write in the chat what's happening. What is GitHub asking you to do when you upload the file? Which stage is emitted when you upload the file directly to GitHub? And yeah, how many files are there in our local repository at this point? And the first error. So if I look at this error, it looks like this file was already present in your local repository. So now you've uploaded a file with the same name on GitHub, but it's also present in that folder where you want to pull these changes towards. So what I suggest to do is that you just remove, what James is now mentioning, remove plot1.r, and then do git pull again, and that should work. And it seems like everyone is going fast for everyone. Well, it's going good for everyone. It's going quite fast. No one is answering my questions, but that's okay because they are maybe too obvious. What is GitHub asking us to do when we upload a file? It's asking us to write a commit message. We always have to give a message when we change something and when we want to save it. Okay, so committing it. Which stage is emitted? It's of course the staging area. Why is it emitted in GitHub? Because GitHub doesn't work with this staging logic. Okay, so it is present on our computer locally, but it's not present on GitHub itself. If you do some changes in GitHub, it's going to be immediately present in the repository. So GitHub doesn't contain a staging area. And how many files are there? Hopefully there are 2 files now, and that should be all. So if I now do ll or ls minus l, as James already mentioned in the chat before, what we see is 2 files, plot1.r and readme.md. I didn't actually explain what MD represents. It represents Markdown. I'm not sure if you already know what this means. Basically, this is some kind of enriching text formatting syntax. So if we would look at this file, what you would see is... So I'm opening the README file. And what you see, if you open it in a plain text editor, is that the introduction GitHub December, so the first line has a hashtag in front of it. Markdown is going to interpret this as this is going to be a title. If we would say we want a subtitle, what we could do is add a double hashtag in front of this and then say this is a subtitle. Okay, we're not going to do this right now, but just to explain you that Markdown is basically plain text, but with these symbols in front and somewhere in the middle or whatever where it can be, it's going to create these titles or bold text or italic text.
Could you demonstrate cloning a repository from getting the URL to typing in git clone again for us, please?
Yeah. For this, I will remove the repository that I have right now. So I'm still at the same level. So first thing that we need is the link, and that is visible, or we can retrieve that on GitHub. And we can find it by clicking on the code, the green code button, and then copy paste the link over there.
Make sure you're copy pasting the HTTPS link.
Yes, yeah, but normally that should be the default one as well. So Control C is what I'm doing now. And then I go to the git bash. And here I did change directory into a folder where I want to clone the repository towards. So here in the documents folder, I want to clone the repository. So what I will do is git clone, and then Control V doesn't work here. So I'm going to right click and then paste the link that I copy pasted, and then hit enter. Maybe it's asking you for your username and password. Maybe it's not. Afterwards, it should clone it, and then it should be visible in your repository. So what we then see is a folder that has exactly the same name as the name that we gave our repository. So in my case, it's Introduction GitHub December. And if I want to work on this project, I can double click it here. In git bash, I would have to do change directory, so cd to Introduction GitHub December. If I do ls-l here, I can see a list of all of the files that are present. Okay, it seems like it worked. So what I will now do is show you how the routine usage works on a project here. And then afterwards, there will be an exercise. So I'm going to go back to my slides. So what you will also will have to do later on is download this file, but let me just first explain how it works. So the first thing that we need to do in a routine usage is make some changes, of course, and then add it to the staging area. So what I will do is I will download this file, and it's now in my downloads folder. It's called plot2. And I'm going to copy paste it in my folder in my repository. So imagine that we created this file and now it's present in our project. What we now have to do to commit these changes is to tell Git first to add it to the staging area. So what we do is git add plot2.r. And then it's giving us a warning because of, this has to do with the line endings. Don't worry about it. It's not an error. It's just a warning. Let me go back to the slides. So we staged the file into the staging area, and we did this with the following option, git add, and then the name of the file. And this will stage this specific file. Imagine that we would have done changes to multiple files. What we could do is use this line, git add dot, and this will stage all of the changed files or all of the new files that are present now. Okay, so what I usually use is just this dot method, because it will do it all in once. The next step is to commit it. So the files that are now in the staging area need to be saved, and this is what's called committing. And what the line that we will use for this is git commit -m, and then the message that we want to give it. So I'm writing it in my terminal. Let me pull it up a bit higher. Not this. Okay, so git commit -m, and the message that I will say is added plot2.r, and then hit enter. And then it's giving us basically some information of what it did. In this case, that one file has changed because we added it. And then it contains 3 insertions, which means that 3 new lines were added. And that is, yeah, it are nitty details of how Git works in the background, just to give you an overview of what has changed. The question in the chat is, so you have to manually add the file to your working directory before you can stage it. Can you reach it from another directory in Git itself? To answer the first question, what I wanted to show you is, imagine that we're working on this project. At some point you might add a new file. This is what happened if I copy pasted this file in the repository. So basically, if you're working on this project, you would be working in this folder and you would do changes at this level. And then from this point, if you want to make a commit, then you'll have to add it to the staging area. So basically, yeah, I hope that answers your questions a bit. Can you reach it from...
Well, you couldn't say add a file that's in C in the top of the directory.
Ah, no. Okay, no. So, yeah, Git is working on this project, and it will help you to manage the code in this project and all of its subfolders, but not in a different folder. If you want a file in a different folder to be added in this repository as well, then you will have to copy paste it here in this folder as well. Okay, sorry, I misunderstood it. Yeah. Okay, so but what we did is git commit -m and added... Was that a question? It's not really clear. I think.
Poa, yeah, your microphone is on. Are you trying to? Oh, they've just muted
Okay,
themselves.
what's a problem? Okay, so we added a file to the staging area, and then we committed it to the commit repository. And just to mention something about the messages, they should be brief, but still say something useful about what has changed. Okay, so try to make it as short as possible, but still as explanatory as possible. And yeah, you could argue about what are the best practices of commit messages. I don't think it's really important to mention it here, but you have some guidelines, some further reading in this link. But just for the sake of the example, and I will create I'm creating a poll in the chat, and the question is, it's not working now. Well, just type A, B, or C then. Which of the following commit messages would be the most appropriate for a hypothetical commit made to our README file? So we have 3 options. What seems arguably the most appropriate? We have some problems with our poll bot. A couple of answers coming in. Most of them are C and 1B. I wouldn't... So let's say that A is too general, right? It's not really informative, especially if you do 5 commits after each other and you've continuously updated the README file. I mean, you won't be able to recognize which change which commit contains which changes. right? So the first one is definitely not very informative. And the second and third one are much better with this. You could argue that B is a bit too elaborate, because later on we will be able to see also what changes exactly were made. So it doesn't really make sense to say what exactly we changed. A bit more general, but still very informative, is then option C. So arguably, option C would be the best message that we could say here. And then it should be clear by now that what we did so far here on our computer is not visible in GitHub. Okay, so all of the changes that we made are on our computer now, and they're not immediately pushed to GitHub. We need to do it ourselves. And that's what we do with the following command, which is git push. And let me first show you that the files are not present. I'm refreshing my browser, and you can see that still only plot1 is visible here. If in the git bash or in the terminal you now do git push, you will see a message. Here also maybe Git will ask you to give your credentials again, so your username and password. So it's making sure that it's you that's doing the changes, but possibly it's also not the case. Git push is the command that we use, and we see some very detailed explanation of what Git's doing in the background. And if we now refresh our browser, we can see that the second file is also now present in GitHub. And with this, we've covered the most important aspects of GitHub. So now it's up to you. I'm going to open my slides again. The exercise starts with add a title to both files. So what you'll have to do is first do exactly the same as what I did right now. So download the file plot2, add it to your repository, commit it, add it to the staging area, commit it, and then push. Git push. And then I would like to ask you to complete the exercise itself, which is, you can go into your folder, then open one of these files, change something about it, and then repeat the process again. Add them to the staging area, commit them, and then push them to GitHub. So I will shortly also show what has been replied. For Hiria, she can't see the poll. Yeah. So now at least you see the results. So indeed, C is what I would say is the most appropriate. While you're doing the exercise, I'll also say that once you're working on the project yourself, you probably don't care anymore that much about the most appropriate commit message. You'll see that if you maybe look at my publicly available commit messages.
I care. I care very, very much.
You do?
I've put a link, by the way, into about suggestions for writing good commit messages. I consider them extremely important.
Yeah. They are important, but yeah.
I'll explain
I'm
why
sinning.
during lunch break if you're interested.
Yeah, it's obvious why, but
Oh yes, sorry. Yes, I'll do that too.
what?
A link. Oh, sorry, Hediat Nani. It's just a copy paste of plot1. I'll put the link to plot one in YouTube channel.
It's a copy paste of plot 1 with that difference that it's plot 2. So I'm going to type in the chat exercise, and then I'd like to ask you to give it a thumbs up if it worked, if you're done with it. And then we know that we can continue. In the meanwhile,
if anyone has any issues, you're struggling to follow, it's going too fast,
yeah,
or you feel like you're not understanding anything at all, please either tell us in YouTube or Discord chat or private messages.
that's it then. So I'm listing all of the things that I did to get at this point. Might be interesting to see. Git clone, change directory. Then I added this new file to the staging area, git commit, and then git push. Maybe I'll copy paste it in the chat as well.
So we have someone who is struggling to add plot2.r. I'm going to call you R. What is the error message?
Where is that a private message, James?
It's on YouTube.
Ah.
Okay, so the error is pathspec plot2.r did not match new files. That suggests that there is no path2.r in the file in the directory. If you do an ls or an ls minus l, you'll see that there's no plot2.r there. So you'll have to copy plot1.r to plot2.r, and I'll type the command in both chats here in a second. Oh, we have a Viking joining us.
Is that Frank?
Yeah, that's Frank.
James, it's not an exact copy, I think, the plot. It doesn't really matter either, but...
No, it's just creating another file, right? So feel free to edit plot2.r to make it different from plot1 if you want to. Oh,
Oh, there's already 9 people that finished the exercise.
On YouTube, there's a typo. It should be cp plot1.r, plot2.r, not plot2.r, plot2.r. Great.
Seems like everyone is fast here today with us.
Yeah, everyone's very fast.
That's nice. Then we can have more time to discuss other things. I still need to do it myself if I want to follow along.
I think we need to challenge these guys.
Title plot 2. So I've changed plot 1. Now I'm going to change plot 2. Now I'm going to change plot 1. Title plot 1. All right, that's it. So now I did changes to both files. What do we need to do? If we want to add these changes to the staging area together, git add dot. Then we can say git commit -m, added a title to both our scripts, let's say. And then last thing to do is git push. Then we can go back to our GitHub repository and open one of these files to see if the title is there. And indeed, now the title is there. title or description, call it what you want. The changes are there indeed. Without any objections, I'm just going to continue. So if you have problems, let us know. Then we pull back a bit on the speed. Right, so what we will now show you is that you can work locally on your project, but it's also possible that the repository on GitHub has changed. So if there are any changes on GitHub, it makes sense that we also pull them into our local repository. So we have always an updated version of our repository. It's updated with the one on GitHub. So besides staging, committing, and pushing, we now also have pulling. And if we want to visualize it, this is how it would look like. Make some changes in the development area, add it to the staging area, commit it, and then push it to GitHub. Now, if there are changes in GitHub, we can say pull them into our development area. So they are now present on our folder. And also here, I'm going to show it first, and then later on there will be an exercise. The command that we use for this is, of course, git pull, as already mentioned. And that will then incorporate the changes from GitHub to your local repository. So I'm not going to show anything. So the idea is that we make a change in the README file on GitHub. So remember that there is this pencil icon, so we can do changes here as well. Any change is fine. Commit these changes, and then you'll see something happening. You will see that GitHub will tell you that we're one commit ahead of our local repository. Will it say that? And then what we need to do afterwards is pull this commit into our local repository by using the following command, which is git pull. And this should probably also not take too long. I've written exercise in the chat, and once again, do thumbs up if you're done. So I'm seeing that you guys are very fast, so I want to also speak up faster. So this is why I'm running over my words. Sometimes I shouldn't do that actually, but well.
Before you go on, there's a question in chat.
In YouTube? Yeah, okay.
On Discord. Is there a way to filter which files I'm pulling? No, because you're not pulling files. And that's as much detail as I'll go into for now. If you're interested in the details, I will go over it in the lunch break.
When I add commit, that works, but push gives the current branch master has no upstream branch. Okay.
Yes, because your upstream branch is probably main, not master. So that means you would need to say git push origin main. I'm
Can
not sure
you
how
type
it's
it?
got into its head that it's
Yes.
master, but I'll put it in the chat.
Yeah. So basically what happened very recently is that before, let me show you, this here, we will talk later about branches, but basically what Git does when you initialize a repository, it's creating this one branch and it's called by default master branch. It used to be called master branch, and now very recently it's changed towards main branch. So it just has a different name now by default, and that's yeah, maybe the origin of your problem. It's also a bit confusing, mainly.
So there's another question. Hediat Nani says
Yeah.
that they've tried to commit, but it says no changes added to commit. That means that you try to commit with an empty staging area. So you need to add stuff you want to commit before typing commit.
What is giving me error? So let me Hiria, can I ask you where you did the changes? Did you change something on GitHub or did you change something locally? She's watching on YouTube, so it will take a second.
Yep.
Once this problem is settled, we can move on, but let's take the time to get everyone on the same level. Also, Hanne, I hope it worked out for you now. If it didn't, let us know. Still no reply on my question. So the idea was that we changed the repository here in GitHub, changed the README file at least to be more specific. So I will do it once again. What I will do is I will add here is another line. Okay, then we need to commit these changes, and what we say, we give it some kind of message, main here added irrelevant file, and then we say commit changes, and now the README file has changed. Our GitHub repository has hence changed, and what we want to do right now is pull these changes into our local repository. So in our terminal, what we're going to do is git pull. And pull means pulling the changes from GitHub to our local repository. If you were to do any changes on your computer, so if you would want to change the title on your computer, what you would do is, for example, I'm going to remove that line again. Okay, Control S to save these changes. Now the README file has changed. What do we need to do? Git add. Now I can do dot to add all of the changes to the staging area. So this is the part where it probably went wrong for you, Hedia. So first, always add the changes to the staging area. So that's the first step here. Then we say git commit with a message, removed the irrelevant line, enter, and then we can say git push again, and then it will tell us that there have been some changes and they're now pushed to GitHub. So if now I refresh GitHub again, what do we see? That line has disappeared again. That also allows me to introduce the fact that here in the list of files that are present in our repository, we also have the commit message here that is So you can see 16 seconds ago we changed this file, and the message that we gave it was this one. Ah, you said upstream, yeah. I will later, so there is a question in the chat which mentions set upstream. I will mention that later on again. James, I guess that you will fix the problem because most of us are done and ready to move on. Okay. Maybe we have the time during the lunch break to fix that error, Hannah. So you're working on an existing repo, that's why it's probably going wrong. We can definitely fix that, but let's do that in the break. Okay, so what I will show you now is that what I did show you right now was how we can create a repository on GitHub, download it, so clone it locally, and then work on that repository locally, right? What's also a possibility is that we create, that we initialize Git on a project that already exists. And that's what we will show you here. So create a new repository locally and then initialize Git on it and then push it to GitHub. I am going to show it to you first, and then there is still time to test it out on a project that you have maybe on your computer already, or maybe make a new project and then start experimenting with this one. Maybe that's the best idea. So we're sure nothing goes wrong. And then if something fails, we still have time in lunch break to fix it. So let me first show you how it would work. The first thing that I will do is I will create a folder and I will call it new project, just to give it any name. And it's an empty project right now. I'm opening git bash, I'm opening my terminal, and I'm going to change directory into that folder. So ../ means that we're going back one level. Now change directory into new project. And I'm going to list all of the files that are present, and you can see that nothing is present there. Even if I do ls-al, you can see that not even a Git repository is, like the .git folder is present, which means that Git is also not active on this project yet. The first thing that we need to do if you want to initialize Git on a project is use this command, git init, which represents initialize, of course. We're receiving the message initialized empty Git repository in this folder. And if I would now again list all of the files that are present, we can now see that this Git folder is present. Okay, this gives us an idea that Git is working on this project. Let's make a file, text document. I'll call it hello.txt. And let's say hi everyone. And then save it. Okay. All right, so now we have a file into our repository. It gives it the extension itself. Okay, so just hello. Okay, and what we now need to do is add it to the staging area first. We can use the dot method. And then say git commit -m, and let's say created hello file. And now what we want to do is to push it to GitHub. Let's say that we're ignorant and we use the push command immediately. Git is going to give us an error message. It's going to say fatal, no configured push destination. It means that Git doesn't know where it needs to push towards. And it gives us some possibilities that we might consider to fix this problem. I will now already tell you what we have to do. Git has nothing to push towards because there is no repository on GitHub yet. So we actually still, as I shortly already mentioned, we still need to create a repository on GitHub, which will then accept all of the files, like the project files from our computer. So the owner, it's me, repository name. It doesn't necessarily need to have the same name, but let's just call it the same for obvious reasons. New project. Test project initialize from PC. Let's say that it's public, and very important at this point, very important, is that we create an empty repository. So we're not going to initialize this repository with a README, nor with a gitignore file, nor with a license. Why is this the case? Because if we would have a file in our repository already, and if we would have a file in our local repository, and we're trying to link them together, GitHub might have problems with like figuring out which files it needs to accept from where.
There are, of course, ways to fix that, but save yourself the trouble.
Like James mentions, let's make it easy for ourselves and create an empty repository. So once created, this new page will open up. And actually here we already have, there might be problems. We already have a list of the commands that we might want to do in order to initialize this repository. And we already on our computer did the following. We did git init, we git added something, we did git commit with a message. The next step that we need to do, and I'm going to skip this line and see what it tells us, is git remote add origin. So now we're telling, I'm going to copy paste this line and I'm going to paste it in here in our git bash. And what we're doing with this command is telling our local computer, so our local project, our local repository, telling it that it needs to link to this GitHub repository with the link that is given over there. Now you can see something that might go wrong. The fact that we're having this master and main difference here. So if you're starting a project on GitHub, now it's called main by default, the branch at least. Whereas if we start it on our computer, it's called master. And maybe that's then the problem that Hannah had. Let's see. Anyway, so git remote add origin. So now we're linking the two projects together. And what we now want to do is git push. And let's see if I don't give anything, if we just use it bare bone like this. It doesn't work. The first time we'll always have to specify which branches are related to each other. It's something that will be clearer when we get to the topic of branches, so this afternoon. But for now, let's see. For now, it suffices if we just do this. Just copy paste it. You can see that there is actually a difference here. Git push minus u is the same as dash dash set upstream. So that's exactly the same parameter. And origin represents the fact that here in GitHub, this is supposed to be our origin, and main represents the branch. So this is why GitHub is telling us that we need to call it the main branch, and our local terminal is telling us that it's supposed to be the master branch. So let's see if we tell now that it's the master branch, what GitHub is going to do. So it seemed like it worked. And if we refresh, exactly, it worked. So it doesn't have any problems with the fact that it's master versus main. So this is this madness of why there are like probably millions and billions of repositories on GitHub, and then suddenly they decided to change from master to main, which like interrupts with all of the tutorials that already exist, with all of the like reasoning that already exists. So it's really confusing. If you see a problem related to master and main, then you know that like the merging, like moving from version master to version main might be the cause of this. Why did it not work with main? Because the repository first already, like the repository with its contents already existed on our computer with the master branch. So if we want to push something to GitHub, actually it makes sense. We need to push this master branch to GitHub. And there is no main branch actually on our computer. So if you want to push our commits to GitHub, I mean, main doesn't really exist. So it's also not be a possibility. After the break, we will actually talk about branches, so that then it will definitely become more clear. So I leave time now to, let's see what else did I write. So these are the steps, and then just once again to mention that Git keeps track of all of the subdirectories that are present in the folder. So if I would have a folder within this folder, it would immediately also keep track of changes in that folder. So you do not have to, I have to say it's more strongly, it is not done to create a Git repository, like to initialize Git on a subfolder. Okay, so this one Git project here will keep track of all of the subfolders and all of the files in there. Once again, ll and ls to list all of the files. And once again, also, if you would initialize GitHub on a project that's already exists, GitHub is not made for storing big data. So if you're trying to also upload data into GitHub, either it's small enough to push on GitHub. In the other occasion, the data files are too large. The setting is 100 megabytes. So if the file is more than 100 megabytes, GitHub is going to give you an error. Basically, unwritten rule, it's not done to push any data to GitHub. So there is still some time. I would like to spend it for you to discover how it works on your computer. So find a folder on your computer with files that is not yet version controlled, but that you want to make a version control of. So that you want to make a GitHub repository from. Or make a new folder if you don't want to mess up a folder that already exists. And then try to repeat the steps that I just did. So git init to initialize Git on that folder, make some changes, add them to the staging area, commit them, push them to GitHub. That will not be possible yet. So create an empty repository on GitHub, and then you should be able to push them. So how do you use it best in practice for a certain research project? You make a local Git folder for version control and another folder for storing your data. Aha. So good question. How do you fix it then if you want data to be present somewhere? Should I already explain? It will be, I will talk about it when we cover the chapter about git ignore. So basically, it is possible for the data to be present in the same folder. And then using this git ignore file, we can write an expression that will tell Git that it needs to ignore specific files. For example, you could say ignore all of the fastq files, and then all of the fastq files that are present in that folder are not uploaded to GitHub, but still all of the like minor files, the scripts, the analysis scripts can be pushed to GitHub. So git ignore can cover the data. It can work with data being present in your folder nonetheless. What's another possibility? Yeah, if you want to publish your data, in theory, there is a system that Git came up with, and that's called LFS, so Large File System, I think it represents. And that is supposed to store the bigger data. I have tried it out, but I don't find it very intuitive. In fact, I actually never got it working. What's a better tactic, I would say, is store the files somewhere else. Maybe Zenodo is a place where you can store them. I don't know. I don't care. Just store them on some platform somewhere else, and then link in your README file, for example, write down there that your data is retrievable following another link. Does Git also store which versions of, for example, Python modules you used in your scripts? Yeah.
So I can answer that one.
Yeah.
The answer is no. That is your responsibility. If you're packaging software, you should use whatever tool that generally your language provides. And for Python, that is at minimum a requirements.txt file.
Some people might. So for Python, it's requirements.txt in the logic of Conda, Anaconda. Maybe some people know that as well. You have this YAML file as well. Usually it's called environment.yaml. And I can show you an example of that, how that might look like. So in my repository, so this whole repository is being version controlled. There is this environment.yaml file. If I open it with Notepad, let's say, then you can see that these are the tools that I install, FastQC, for example, and a specific version. So like James mentioned, it's up to you to cover this aspect of, let's call it, reproducibility. I've typed in the chat exercise Git initialization on your own local project. I will give it a thumbs up, and it would be nice if you do the same if that worked out. For the people that are
quick,
yes,
are you serious? You've done all of that in 3
usually it
seconds?
doesn't go that fast. So for the people that are done very quickly now, should I elaborate on the things that we've seen so far a bit more specific for, I don't know, do you have a use case in mind that we might already discuss here? Or is there something that I should like tell more about? 9 people. How many people are watching the stream, James?
13, so 12, not including me.
12. It's quite all right. The staging area. Yes, let's take this as a last example before we go into a break. As everyone is already done, apparently. So why the hell is there a staging area? Right? Because any change that we do, we always have to add it first to the staging area, and then we need to commit it, and then we need to push it to GitHub. That's like so many steps. And why is that staging area even there? Because we could as well just like commit it directly, right? There is a very specific reason, and that is more interesting, let's say, if we're having a complex project, let's say. A complex project in a way that we have multiple files and we might work on these multiple files at the same time. Imagine that you have some analysis, and in order to do this analysis, you have 3 different scripts, and today you want to start working on a new feature that you want to add. And for this, you need to make changes to scripts A and C. But somewhere in the middle, you've also seen a mistake in script B, and you already fixed that as well. So now you have changed 3 files, A and C, which contains changes that are related to each other, and changes in script B, which are not related to A and C, at least. So the strength of GitHub is that at, at any point, let's say in the future, we can have a look at our repository in the history. So at any point now we can see in the history what we've changed when. And if we committed all of the changes that are related to each other in the same commit, we can also be very specific as to which things we might to throw away. So imagine that in the end, this new feature that we've added in script A and C, we're not happy about it. We can remove them very easily if they are committed together. So this is why the staging area is there. It's an extra step, but it allows a lot more flexibility and specificity as well, let's say. So what you would do is add the changes that are related to each other, so script A and C, into the staging area, and then commit them with the text. For example, I added this new feature in this commit. And then later on, you can also add script B to the staging area, and then you can say fixed git commit and the message, I fixed this error. And then let's say tomorrow that you don't want this new feature to be included, you can just remove that commit. It's a bit more, yeah. Let's say that you really need it in the beginning, but later on you would be able to say, I want to revert these changes. I want to remove all of the changes from this specific commit, and then you can do it very easily. Whereas if you would have changed if you would have added all of these changes in the same commit, then you want to remove all of the changes of this new feature. You would also remove this error that you fixed in script B. Does it make kind of sense?
This is a neat little way to remember this. Commit early, commit often.
Where is all right, so it's branch early, branch often. That's still something else. Yeah. It doesn't cost you anything to commit.
Except coming up with a good commit message, remember.
But it still costs nothing to commit. So it's better to do it often than, rarely.
I can show what you were trying to describe visually during the lunch break, maybe.
Yes, let's have a lunch break indeed as well. What would you say? Do it right now or like 5 minutes before the end?
Have you still got stuff to cover that you wanted to cover before the lunch break?
No. So this
fine,
is a nice time to have a break.
All right, let's do it now then. I will be sharing my screen. I've got a couple of things I said I was going to cover. The details or elaborations on what Tour has been talking about. So feel free to go and get your lunch if you're not interested. So only if you're interested, stay and watch for another 5 minutes or so.
I'm going to stop my screen sharing session and then I will follow yours, and then people on YouTube can also follow.
Thank you. I'm just going to set up my screen a bit. Okay. Hopefully that's going to come through. I'll wait until YouTube.
Can you choose one screen, James, maybe?
Oh, can you see all three?
Yeah.
Okay, let me try. How's that?
Small.
What do you want from me?
Control plus.
Oh, the text. Okay, yeah. I can fix that. Well, the text isn't really. Yeah, I can do that.
Okay, maybe on the left-hand side as well. Oh.
Well, left-hand side's not useful. I'm going to close that.
Okay.
So, and I need to turn off push to talk. Okay, hopefully you can still hear me. So here is my Git projects, and I've got a whole bunch of files I've changed. So let's look at one. Here's a whole bunch of changes that I've made in here, and say I only want these changes. I've made all these changes, but I only want to commit these changes. Then with Git staging, I can stage just these. So here are all my unstaged changes. Here are now my staged changes, and I've staged just this little bit. So now I can commit these without worrying about all of the other changes to the same file that I've made. So if you're interested in, if you're silly like I have been now, and made lots of changes without committing, then here is how you organize yourself using Git staging area. Hopefully that makes sense. The next thing I wanted to show you is why is it called clone rather than download or something. And for that, I kind of want my document camera, so I'm going to stop sharing my screen, and I'm going to switch on my camera. Not that one, but that one. Okay, yep.
It's loading. Yeah, okay.
Right.
It's a bit off, but
Yeah.
yes.
Okay.
Yeah, perfect. Great.
Okay, so here is to computer. Here is GitHub, and here is me. We have our repository here now, and this axis is time. So old, new. So 2 makes a commit, which I'm going to represent as a dot here. And then 2 makes another commit. So we've got 2 has got 2 commits in his repository. Then he pushes this is called a tree, and we'll see why it's called a tree a bit later. So now he's pushed that to GitHub. So GitHub has these 2 commits as well. Now I don't have a direct connection to. If I did, I could clone his tree as well. That's why it's called cloning, is because I want to clone this tree. I want to get a copy of this tree. So I make a clone of this tree, and now I have the same tree. So now maybe I make another commit, and then I want 2 to be able to see these changes. So I can push my tree here, but I don't want to push the whole tree because that could be huge. There could be thousands of commits here. So Git is a bit smart, and it says, all right, this is the only change. These are the only commits that James has made on this tree. So I'm going to only push that commit to GitHub. Great, but 2 still hasn't got it. So he has to pull this tree again. But of course, Git is still a bit smart, and it says this is the only commit that is different between 2's tree and my tree. So it only pulls. This is a pull. This is a push. This is a clone. It only pushes. 2 only pulls the commit that is different from GitHub. So there is the reason behind these command names. Hopefully that makes sense to anyone who might be watching. Done.
Nice, but
okay, I'm going to stop sharing my video now.
It's also a nice way of having another overview as to how Git works, right? Like pulling to GitHub and pushing, pulling from GitHub, pushing towards it, and having the same copies.
The important thing to recognize is there's no one who's special here. There's nothing special. No one, neither 2 nor GitHub nor me, is special in this relationship.
You're referring to the distributed
Yeah, so it's
fact.
Git's called a distributed version control system. It just means everyone has a copy of this tree, and if I had a direct network connection to his computer, I could pull and push directly from his tree if I wanted to. You can even pull and push and clone to different directories in your file system, but I'm getting into too much detail now, I think.
Yeah. But basically, the distributed refers to the fact that the repository can be anywhere,
Yeah.
and everyone is equally important.
Everyone's equally important. Yeah.
All right. I wanted to start again at 1, if that's okay. Still 45 minutes break. I think that's okay. So I'll type that in the chat as well. And then we'll see each other again at 1.
Wait, who is it? Yeah.
James, James, mute yourself. Test. Okay. James, are you already there? Not yet, it seems. Hello, yeah, okay. I'm checking if everything still works. The live stream is up now again. Yes. All right. Grab another glass of water. Hello again, everyone. I hope you had a good break. Someone asked me in a private message if it's possible to have a certificate of attendance for this workshop. Obviously, this is possible for the people that want to use it for doctoral schools, for example. The easiest way for me is if you would write me an email, and I'm typing my email address in the chat. You also have it because I've already sent you an email, of course. But I will also mention it again in a follow-up email after the course. So if you send me an email and ask for a certificate, that would be very handy for me, because then I am sure I'm not forgetting it. So up till now, let's have a quick recap. We've learned a bit about why we should use Git and GitHub, so version controlling systems. We've also learned how to initialize repositories, how to make one on GitHub or locally. We've covered the basic usage, so the routine usage of adding, committing, pushing, and then also pulling. And these are the most important things, but, and this was mentioned in the beginning when I asked why are you following the course, the main reason people usually follow this course, and it's also here the case, is because your lab is using GitHub, for example, and you need to collaborate on a project there. Or maybe you just need to collaborate with someone else on a project and you want to share the code. And this is things that we will cover now in the afternoon then. So first I'll very quickly going to describe something about status and the history, and then we will talk about branches and collaborating strategies. In GitHub, this is often called the fork and pull method workflow. I will get to it. So yeah, let's get started. So we've used the add and commit commands a lot in the morning session. But what's sometimes confusing or might be confusing is that you're not really sure if you already added some changes to the staging area, or that you maybe not sure if you already committed the files in the staging area. Maybe you're also not sure about which files are in the staging area, and git status is your best friend for this. Status is something which I'm using all the time. If I git add files to the staging area, I'm going to type git status and have a look if it worked out well, if the files are indeed in the staging area. Idem ditto for the commits repository. So why do we use git status? To get an overview of which files are in which status. And if I would run it on my terminal right now, and I'm going to drag it in again. So for your information, I'm still in the repository that we created this morning together from GitHub. So the introduction repository. And if now I would do git status, Git is going to tell me something about the status of this project. More specifically, it's going to tell us we're on the main branch, and more on this later, and that this branch is up to date with origin main. This basically means that all of the commits that we did in this project are also up to date with the ones in GitHub. You cannot blindly trust on this line, but it gives you an idea at least. And then it also tells us that there is nothing to commit and our working tree is clean. So for the sake of the example, let's make a change to a file and see what is happening then. I'm opening again my folder system here. I'm going to the repository that we're in. Let's say that we change the README file. And let's add that irrelevant line. No, let's make something useful. Author equals Tuur Malemans. Okay, so I'm writing that I'm the author. So these changes are done on our computer. And now, if I were to git status, Git is going to tell us something different. The two first lines are exactly the same. If you're following on the slides, you can scroll to the next slide. So the two first lines are exactly the same, and then there is something new. Now Git is telling us there are changes that are not staged for commit. So this literally means there are changes that happened, but you didn't add it to the staging area yet. And then it's giving us two suggestions. The one is use git add to update what will be committed. So this means to add it to the staging area. Or what we could also do is git restore. And that will then discard the changes in the working directory. So this is another way of how you can control the changes that you've already done since the previous commit then. So imagine that I'm just going to show you what's happening, right? Git restore and then the name of the file, it's the readme file. Enter. If now I have a look again at the readme file, you can see that the last line that we added here, so the author is disappeared again. So from Git, we've now discarded the changes that we've made at this point. Let's write it again after two elements. All right, changes are done. Git status, it's giving us again the same result, but let's now add it to the staging area. So git add readme. And now I'm going to use git status again and see what's changed in the status of our project. Once again, the two first lines are exactly the same, but now Git is telling us another suggestion. There are changes that can be committed. And the changes that can be committed are then listed here in a, well, depending on how many changes you have, but in a long list. So each file is then, that has changed, is then one proposed change. So you can see this readme.md file has been modified. Also, at this point, we can say git restore --stage staged to unstage these changes. What does it mean? The changes that we just did and added to the staging area, we can now remove it from the staging area back into the working tree, let's say, in the development area, let's say. So this allows us to remove files from the staging area that you don't want to commit together. Because as soon as we now do git commit, all of the files that are in the staging area are being committed together. And let's see what git status now tells us. Now, first line is the same, but it also says your branch is ahead of origin \main. by one commit. So this means that we've been working on our computer locally, we've changed something, we have committed it, and now we need to push it, and that's also what Git's telling us. We need to still push it in order to publish these local commits. Basically, Git is telling us everything what we should think about to do. And then for the rest, there were no new changes. Imagine that I'm changing yet another thing. We're getting back in the same circle. If I now use git push, also here, if now I do git, so now the repository in GitHub is up to date with the one here locally. If I do git status, we're back at square one. Why did I tell you earlier that you cannot blindly trust this line? What I'm trying to say with this is, if the GitHub repository has changed, so imagine that James has changed something on the GitHub repository, then locally it won't say that the GitHub repository is one commit ahead. It's not going to tell us that there have been some changes. And this is very important to understand then, that if you're working on a project together with someone else, that you think about git pull a lot. Because by pulling all of the changes in the GitHub repository to your local repository, we'll make sure that your local repository is always up to date with the one on GitHub.
If I can interrupt, that sort of revolves around mechanisms of how you work together on a single code base, and we can get into that a bit later.
Yeah, thanks for mentioning that. So the slides are a summary of what I've just described. Then there's this history thing that I want to explain, which you can access by using git log. I didn't type that in the chat, in the slides, but if you were to use git log, and that's now also in the Discord chat, you get an overview of the history of your project. More specifically, if we look at the slides again, you'll see a long list of several blocks like this. And it contains a commit ID. It contains the author, information about the author, about the date as to when the changes were happened, and then the message that is accompanied with these commits. So if I look now in my terminal, in my git bash, you can see that it's working from most recent to the oldest commits. Okay, so the first one listed here is going to be the last one that we did. So you can see commit with an ID, and then author, date, and then the description added author. The previous commit had this ID, author, also me, date on 11/39, and what we did was removed the irrelevant line. So this gives you an overview of all of the commits that you did on this project. You can see that the list has not ended by these colons here. So what can you do to get out of this page is use the letter Q. It's also in the slides, but I'm just explaining it here now. So git log again to have an overview of the history, and then use the spacebar to go to the next commit. And so we can scroll through the commits. And James is already giving a suggestion. I will come back to that.
It's for advanced fast people, maybe not for everyone.
So yeah, what I still wanted to say, as we're going fast through this course and everyone grasps all of the concepts real nice, what you see here is an ID, right? This is actually a hash that Git is calculating based on the changes that you did from the one version to the next version. So from the one commit to the other commit. And it's not really worth going into the details. I can't even explain how it happens, really. But what is important is that you can not only on the comment here, but also on the hash have a very specific ID of which commit it is. Not really well explained, but what I want to explain, I will show you. You can see, for example, that the last in GitHub, the last commit that we did was the one removed the irrelevant line, and it contained this hash. So that's the ID of the commit. And it's basically a short way of describing the longer commit, which is here 732A413. Here you see the same hash, 732A413. That means that now I have to refresh my browser because I already pushed it. That means that you now can see. Nu is die hash daar niet op. You can see. Git log. You can see that the latest commit in our local repository, which bears this hash, is the same as the one in GitHub. And then we can be sure that this is also, like, they're up to date now. And indeed, like James mentions in the chat, no commits will ever have the same hash. So this is really a unique identifier of a commit. So these are some of maybe a bit more advanced or more technical things.
Well, it's potentially useful. Maybe I can give a quick use case for why you'd want to know then. Say you've got a long history and you remember last Thursday, you produced a plot that showed exactly what you want, but somewhere between now and last Thursday, you've changed your code and it no longer produces that plot. Well, you can go back to the Git hash, the hash for that commit you produced last Thursday, check out that commit, and voila, you're back to producing the plot that you had last Thursday.
And this is a more waterproof way of going back in commits history than just based on the message. Right? So thanks, James.
Sure. Well, you can find the commit by the message, yeah.
Yeah. Okay, but then maybe you have two similar messages, like I added a plot.
Yeah, indeed, yeah.
And then, yeah, you can separate which one is
another
which.
reason for writing good commit messages.
What? Yeah, another reason. Yeah, indeed. And then what James also mentions in the chat, and which also relates to the aliases, which I wanted to, which I mentioned in the configurations file in the morning. Here we can also add a bunch of these parameters, which will make it a bit more overviewable of how the history looks like. So what can we do as well? We can say git log one line, for example. And then we'll have an overview of all of the commits on one line, starting from the bottom, initial commits, all the way up to the last commit that we did. And besides that, of course, we can have many other stuff. Maybe git log one line decorate is something nice. No, it's pretty much the same. Okay, but you can imagine that you can extend this command with a bunch of these parameters, and you want to use it like as your default way of having an overview of your history. So what you then can do is write aliases. And this is, if I call my global configuration file again, this is what you see in my case here. Let me do that again. So you can, let me make it even larger and do that again. You can see that I created an alias called mylog, one that's called lol, one that's called ll, one that's called hist, and they all bear this extensive list of parameters. So now I can say I want to use my pre-made alias called git hist, and then I have something that looks like this. You can find a bunch of them on Google, how other people use it. I'm willing to share mine as well if you're interested, but voilà. So now you have an ID.
To
Yes.
exit the git log paginator, you press the Q key.
Yeah. So if you were to be stuck here, I was too lazy to type it out in a nice slide, but basically this says something about the paginator of the history.
But by the way, could you run it with the graph, because that displays the tree I was talking about?
Yes, but then maybe
tree.
I'm going to another repository where it's maar ik heb daar geen. I'm thinking about a repository that contains branches.
The Python one?
Python one, yeah. And then
Or you can save it until we talk about branches if you like.
Well, we can already do it here. What's the exact
And one line. Graph one line all.
I don't know it by heart.
Yeah, that's without the
Ah, nice.
So there's a nice tree of the Git history in this repository for demonstration purposes.
Yeah. Once we talk about branches in a second now, it will make sense what's happening here. Let's talk about it later. Question for everyone is, if there are any questions, please type them in the chat. And then also, or otherwise, can you tell me why it is useful to have the author's name and email addresses in the history log? Which is maybe too obvious of a question.
Am I giving too much away there?
No, but that's even better. If you understand James's GIF.
If you understand that GIF, you don't need to be in this course.
For the other ones,
so if you want to type the answer in chat, feel free to.
Yeah, I was thinking of waiting for a second. Maybe in YouTube it comes in later. It's all your fault. All right, doesn't seem like it. So indeed, it's especially useful when you're collaborating on a project and you want to figure out who has done what changes. And in the case of James, is suggesting, imagine that you're not happy about someone's changes, then you can blame the person that did those changes.
Is now a time to do a quick example of a git blame? There is a command, git blame, by the way.
I've never used it.
Can you bring up the terminal and just one of the notebooks in the Python training? One that we've both used. It'll make it more interesting.
Which one is that? Let's see the list.
Maybe the intro one. Intro? Oh yeah, that's what I brought there. So if you do a git space blame space that file name. So now what are we looking at? We're looking at...
I'm going to make it a bit bigger, yeah.
The left column is the hash. The next column over is the file name. The next column over is the author for that line. The next column over is when it happened. The next column over is the line number. The next column over is the source code that was changed. So we can look at, the line that's highlighted there and say, why was this put here? And then we can look at the hash and go to the git log and say, and James will have written, for this excellent reason, I changed this line number 21 to the if statement. So that's another reason why good log messages are useful. But this is an example of blaming here.
Nice, thanks, James. I usually don't go so deep into it, but yeah. No
I
questions.
suppose you can also send nasty letters to their home address with this information. This James Collier guy, just terrible commits all the time.
You don't want to work together with him, I'm telling you. All right, enough rubbish told. Next up is branching and merging. And I will start with, let me see, 1 second. Yeah. So I will shortly introduce what it is and then also show you how it's done. And then there will be an exercise and then you can do it yourself, which is basically going to be some kind of repetition. That's making a branch, and then we also need to merge maybe the branch back into GitHub, and then we can use pull requests. I will talk about that as well. Basically, these are two different ways. You can do it either on GitHub or you can do it locally. You can start doing it locally at least. That's also a command for that. So I will then at the end also explain how you would do it locally. Then, of course, after you've used a branch, you can also delete it. And now we're getting also more towards how we can collaborate on projects. But let's start by explaining what a branch is. And we've already mentioned that when we create a repository, by default, Git or GitHub is going to create the master branch. And as I also explained before, it's either master or main, thanks to GitHub changing the names of the default branch. So it's either master or main, and I will now always talk about master to try to avoid any confusions. Why do we branch? So let's say that we have a project and you already have a very nice basic form of this project. Imagine that there is code in there. This code does exactly what you want it to do. However, at this point, you want to do something extra. And you want, for example, to make a new plot. But what you don't want to do is mess up the code that already exists. In normal circumstances on your computer, what would be possible is create a copy of that file and then try to do some changes in it. And then if you're happy about those changes, you keep them in some kind of way. But there is no really good way of how you can do that. You might end up with version final and version final, version final, or something like that. It's going to be messy. Git has a very nice way of structuring this type of work, let's say. And more specifically, you can do that by creating branches. So the default branch is the master branch. So let's say that this is our project at a specific time point. We can then create a branch, which is basically, you could think of it as a copy. And then in this branch, in this copy, you can then do some changes. And at a certain point, if you're happy about them, you can merge them back into the original file. And this point is very important to understand, that the original file will always be present. and this branch is like a copy that lives next to it, and it has a completely separate life, then only when you say that you want to merge these files together again, only then you will merge these new changes into the original file again. And then that brings us to the fact that you can create as many branches as you want. So it just like commits, it doesn't cost you anything. Generally, we say branch early and branch often. As soon as your code exists and it does something that you're fine with, let it be as it is in the master branch. Create a branch and a separate branch, which you call, for example, new feature, and there you add that feature that you want, and then only afterwards, if it works, merge it back into the original branch, so in the master branch. And do that, for example, for each separate feature, even though they run parallel, like create branches as much as you like. There are two ways. You can create a branch on GitHub, or you can create a branch locally on by using our terminal or Git bash. And then, yeah, create branches for each new feature. And I will show you, I will start showing you now based on GitHub. So what we need to do is have GitHub open again, of course. Let's see if we're in the latest version. Refreshing seems fine. What we now have to do to create a branch is click here. In this case now my default branch is called main. Could as well be master, depending on how you start it. This as a side note. Here will be a list of all of the branches in on this project. I'm going to answer the question in the chat for everyone. Will the branch stay once it is merged with the main branch? Yes is indeed the answer. So the branch will still exist. Imagine that you're working with 10 people on the same project. Everyone has 10 branches. It makes sense that once a branch is merged in, this project, this feature is closed, so to say, then you also delete these branches. We'll do that at the end of this chapter. So now here we only have one branch, which is the main branch, which is also the default branch. And now I will create a new branch. It's called new feature. And I can create it by clicking now on create branch, new feature. And what's happened now is branch created, and you can see some information about this branch. It's even, so it's a different terminology now. It means that it's basically the same as the main branch. Of course, because we didn't do any changes as to this point yet.
Can I maybe try and illustrate what that's referring to?
Yes. How you want to show or what you want to do?
Yeah, video. I'll have to turn on push to talk as well. Okay, hopefully you can hear me.
I'm going to pull you up here, and then I have to stop sharing then. Okay. Stop streaming. Of course, streaming. All right.
Issue, sorry to. Can you see me?
Yeah. It's fine. It's fine. Great.
Okay, so this might be master is just a label. So this is what we're labeling master. And then when you do a branch, initially it's just going to be, the label is going to be pointing to the same one. So this might be new branch. Sorry, so that's what it means by even. These two labels are pointing to, oh, that's way out of focus.
Because, no, it's fine. It's kind of readable. It's just your how you write is not really readable.
Okay, well,
No,
the
no, no.
important bit is that these are two labels that we're calling branches. Then, say you add a commit to new branch. So now the new branch label no longer points to there. Now it points to here. New branch. Master still points to here. So we can still add commits here even. So if we add a commit to master, now the master label points to here. And we can continue in parallel here for as long as we like.
And at this point, the branches are not even anymore.
Indeed.
Shall we have a look at how it looks like on GitHub?
Yep.
Ooh.
In fact, you can visualize this on GitHub too.
Yeah, maybe we'll do that as well. That would make sense indeed. So we created the branch. Let's say that we make a change now in GitHub. Let's say that another author is now also James. Is it double L James? Yeah.
Yep.
Yeah. So I'm making a commit in this branch. You can also see that we're committing directly to the new feature branch, which means that we're committing this change, this commit to that branch. And then we can see that this branch is one commit ahead of main. This means if you think about the picture that James just drew, the right-hand branch, which contains our new commit, is now like one dot below. So it has one commit.
You can see this under the Insights tab. And I forget what it's called, network.
Hey, that's new. It's not really visible here because main is overlapping the branch here. Ooh. But now you can see all of the commits that were part of the main branch, and then we created a branch, new feature, and then did a commit there. And even means that they're on the same level then. So far, so good. Yeah, so now I'm back on the main branch, and you can see that James is not an author here. He's not listed as an author. If I switch to a new feature, so I click on main, new feature, now we will see a version of this project in which James is an author. So this file is different. We have an overview of the difference between this branch and the main branch, in this case, one commit ahead. And then also, if there are changes, normally GitHub will propose to you if you want to merge these changes again together. So this means merge the changes of new feature into the master, the main branch. So let's do that for the sake of the example here. Click on compare and pull requests. So merging in the terminology of GitHub is called pull requests. I didn't explain that yet. So we need to make a pull request. And what do we want to pull? We want to pull these changes from new feature into main. You see the arrow points from the right to the left, means we're adding the things from the right to the left. It's also going to figure out if there are any problems. Imagine that we've changed the same line at the same time. Then it might give us an error and we might need to fix that first. In this case, there's no problem of merging the files together, the branches. But in this case, we're just changed one file, so we're merging the files together. These branches can be automatically merged, so that's also nice. What we can do here now is give it a message as well. For example, added James as an author. You could say incorporate new feature branch with James author. Could also be a possibility, I don't know. Whatever works for you. You can also leave a more descriptive comment, but also this is not necessary, and then create pull requests. A new file, a new tab pops up. So now we've created a pull request, and it's also visible here in the repository under pull requests. So if I would click on this, you can see that there could be a list of all the pull requests that we might think about to do. In this case, there is only one. If we click on that one, we have the same tab that opened when we created the pull request. You can see what has changed in the commits, for example. Only one commit, namely I added James as an author. You can see an overview of all of the files that have changed. In this case, we've added James Collier as an author here. It's because I didn't write an enter, hard enter, that he thinks that this is one line actually. It's details, I guess. Checks. Let's forget about that. And then here, it's stated as a conversation. We can have a conversation about this. So we have a list of all of the changes that I want to incorporate. And imagine that James is collaborating on this project. He also has a possibility maybe to merge these pull requests. And here you could say, here we could have a discussion about this. I could say, James, could you have a look at this and accept pull request? I'm not sure if the add is going to, yeah. So I'm working on my personal repository. Imagine that I'm working in the team's repository, then I could tag other people as well. I can leave that comment here so we can have a discussion here. And then finally, if we're all happy about it, we can say merge the pull requests and then confirm the merge. We're getting a message pull request successfully merged and closed. And now it's also suggesting to us that we can remove, so delete the new feature branch. Can already do it here. Man, GitHub is changing all the time. And what we see now, if we go to code, we'll have a list. Well, we'll have the main branch that now also contains the changes that we did in the feature branch. Let me come back to deleting branches later. It's not important at this point. Click on. So I've discussed all of these things now. The pull request should be interpreted as a request to pull the new branch and all of its changes into the master branch. Okay. Master is the base where it would be pulled towards, and the new feature branch is the branch with the changes. And GitHub checks the compatibility, so it means that it's going to figure out if you can incorporate these changes. And then give it some comments. We all discussed this. So then it's up to you now. For an exercise, and I'm giving a suggestion of what we could do, try to do it on GitHub still, please. Make a new branch in GitHub, edit a file, make some changes to it, and then commit them and merge them back into the master branch and see how it goes. Good question already at this point. Can the opposite also be done? So merging another branch with the main branch, if the main is ahead of the branch. Yes, and yes, this is also very important because so you might make a new branch and you might do some changes in that branch, but someone else might be changing the main branch as well, right? So this is it's important that you sometimes try to update your branch with all of the changes that have happened in the main branch or in the master branch. So the other way around is also possible, and you can do that. Maybe I will very quickly show you. Shit. Yeah, okay. Nee. So in the main branch, I will just type an enter here and then say enter and then commit these changes. I just want to be quick here now. I'm going back to the repository. If I now click on new feature, you can see that this branch is 2 commits behind the main. So this would be a reason why we can pull the changes from main into this new feature branch. And also here, sorry if I'm going too fast, you can click on pull requests. And then you can switch the bases around. So now you want to incorporate the changes from the main into the new feature. And then you can do it the other way around. I'll just leave it by this, but you can do it as well, of course. I'm going to type in the chat exercise, just like that. And then if you could do a thumbs up, if the exercise, as I stated it here, worked out for you. Any other questions at this point are also welcome, of course. For the people that are already done, let me just tell it like here for everyone. We've now created a branch on GitHub and we did some changes there. What do you think that we need to do if we want to have this branch also locally? So you can see that merging a branch into the main branch, for example, or the other way around, it contains a lot of steps in GitHub. It's okay, then we're sure that nothing goes wrong. But it takes a couple of steps before we merging a branch into another branch. And to summarize also again, in the GitHub terminology, it's called a pull request. I'm quickly going to do it myself, so I also have the same repository as you have. And then we can go on with the next part. Oh. So you can see I want to do it fast and I'm not thinking about the commits messages, right? It's not good. So maybe very shortly to elaborate on collaborations strategy. Imagine that you're working together on one project. It could be an idea, for example, to have the main branch as the centralized branch, which no one touches. And then, for example, for James and me, James has his branch where he can do changes in, and I can have my branch where I do changes in. And then at any point, we can say, it looks fine for me, for example. I want to merge these changes back into the original branch, so in the master branch. Then I can create this pull request. I can tag James here somewhere, and then James can have a look at all of the changes that I did. And right here, he can say, okay, I like this, or I don't, this line, I don't like it. I want to leave a comment here. You need to change this, for example. And then only afterwards, he can also decide to merge it in if he's happy. And so you're both in control of who's doing what, and you can check on each other as well. Yeah. Imagine that then the main branch has changed because my changes have been merged into the main branch. Then what James probably needs to do is do git pull or merge the changes from the main branch into his development branch, and then he can work with the new updated code that we have there. And that's basically, this comes down to what's called rebasing. That's what James mentioned in the chat. So if you're rebasing, what you do is pull the changes from the main or the master branch into your new feature branch, for example. So it's up to date with the main branch. And then if your code still is fine, if your new feature still works out fine, only then create a new pull request with your changes into the main branch. That will be the easiest way to merge changes from different branches that often change a lot. The question was earlier, what do I have to do to have these branches that we created here in GitHub also locally? Well, indeed, git pull and ooh, I'm in the wrong branch now. And you can see that a lot of lines have been given here, but this one might be interesting. Now also we have a new branch called new feature, and yeah, it also directs towards in GitHub the origin new feature branch. And then I'm going to open the slides again because there is a list now with all of the commands related to branches that we can use on the command line. And let's have a look at them one by one. So git checkout -b is going to create, followed by name of a branch, is used to create a new branch and immediately move into this branch. Git branch, followed by a name of a branch, will just create a new branch, but it will not move into that branch. It will just stay in the main branch then, or the one that you're already in at that moment. Git checkout is the command that we use to switch from one branch to the other. And then git branch -a is going to list all of the branches that exist. So let's start with the last one first. Git branch -a. So what do we see? All of the branches that exist remotely. So this means in GitHub, and then the ones that exist here in Git locally. So we just pulled the GitHub repository in on our computer, and yet for some reason this branch is still not explicitly present. It's just telling us that there is a new feature branch in GitHub. So what we need to do to access it is just using git checkout and then refer to the name of that branch. And then Git is going to tell us that he switched to a new branch called new feature, and that it's part of this remote branch new feature from origin, referring to the repository on GitHub. And do you see also this has been changed? So we've went from main to new feature. So this is telling us now that we're on the new feature branch. It contains the same files. Yeah. Imagine, for example, that I want to create a new branch. I can do that by git checkout -b, which represents branch, and then say test branch. And now if we git branch -a, list all of the branches, now we can also see that we have a new test branch, and we're also in that test branch immediately. Yet it doesn't exist yet on GitHub. So what we would have to do is git push to push these changes. So meaning telling Git that there is now also a new branch. Let's go back to the slides because I'm deviating from what's really important. One very important thing to mention here is the difference between git checkout and git checkout -b. Especially the first time that you want to incorporate a new branch. Imagine that I did here git checkout -b, new feature. What would have happened? I would have created a new branch that's called new feature, but it would be a different branch than the one that lives on GitHub, yet it bears the same name. And also here, it's going to cause problems. So you really need to pay attention to the branches that already exist in GitHub and if you want to incorporate them, and that you use the right command here. That being said, to have an overview of what could happen, for example, you have a master branch where you might do some changes, and in the meanwhile have another branch, new feature branch, that contains other changes. You can move from one branch to the other with git checkout. The first time you would create a new branch with git branch, or git checkout -b, and then do some changes here, git add, to add them to the staging area, commit to the repository, and then push to GitHub. So here is another list of commands that you might want to do if you want to create a new branch and add some changes to it and then push it. So this is, yeah, this is another important aspect here. The fact that if you use git push, it's always better to describe explicitly from where to where you want to push. And from where, I mean from which branch to where to which branch. So imagine now we're in this test branch I've just created. And let's make some changes. I will detach plot3.r. So this will create an empty file plot3. If I list all of the files present in this repository, in this branch, now you can see that also plot3 is a file here. Git status is telling us that we're on branch test branch, that we have untracked files, meaning that there is a new file, but we're not tracking it yet with Git. So what we need to do is git add dot or git add plot3. So now Git is telling us we're on branch test branch. We have changes ready to be committed, and we can do more specifically this one file. So let's do that. Commit min m created plot3. And now you could say git push, and normally, hopefully, Git will figure out by itself that it's a new branch and it needs to push to the correct new branch in GitHub as well. So it will create one then. Yet you can be more exact, more precise, and safer hence, and say git push and take the origin, so the repository on GitHub, but push it to this new branch that we will call test branch. And once you've done this one time, from this point on, you can normally be safe that when you use git push in a specific branch, in this new branch, that Git is going to figure out by default where the changes from which branch need to go where. Okay, so imagine that I make another file now, git touch plot4.r. Wrong, doesn't really matter. Git add, git commit. And now I can do git push. Now if I refresh this page, then you can see that plot4 is also here in the branch, test branch. And if we look at the main branch, we can still see that it's only contains the two previous plots. I'm sorry, two previous plots. I hope that makes sense. Let's have a look at the slides again, because now there is an exercise. So let's have a look now locally and try to do again what I just did. So make a new branch. Remember that there are two ways. So if whatever way you use, make sure that you're in that new branch. Make some changes, create a new file, or edit something to the README file or something like that, and then stage them, commit them, and push them, and see if it all worked out fine. And then later on, maybe also see if you can merge these changes in GitHub as well. So create a pull request and merge them back in. Maybe that's also, I'm sorry, I'm going to interrupt once more, because it's also quite nice to see how your local file system is working. So pay good attention of what's happening here. I'm in my folder in my repository introduction GitHub December, and it contains plot1 and plot2 and the README file. And you can see in git bash, I'm in the main branch. Remember that in the test branch, we added two files, plot3 and plot4. If I do git checkout to that branch, so test branch, look what's going to change here. Enter. You can see that now there are two more files here present. So we're still in the same folder, and by using branches, we can, in the same folder, make it, go from one branch into the other branch and have like all of these different versions of the same project present. Nice. So the files of the different branches are indeed in the same folder locally, but depending on which branch it is, so imagine that one branch doesn't contain a specific file, it will not be visible. Git is in the background figuring out for you which branch has which files. We can't see the whole screen in YouTube. Okay. Let me see if... this contains everything. This also. Couldn't see the last commands. It's down and there's the video. Ah, yeah. Okay. Yeah. So you can't see it because it's here in the bottom. Let's see.
Did that answer your question about the difference between Git's branches and the file system?
Oh, sorry. I will pay attention to it, Heria. Okay. So not that many people are done with the exercise. I will wait a bit longer. We have plenty of time, of course, so don't worry. Yeah, that's a good point. Remark of Chia is, I'm still wondering which branch do I see when I'm not in the terminal. That's a very good point. And
The same one you
basically,
see when you're in the terminal.
sorry?
The same one you see when you're in the terminal. So,
Yeah, but James, what she means is that if I open my file explorer here, you cannot see it. You don't know from Windows whether this is Git version controlled and in which branch you might
I see.
be.
Sure. Yeah.
So that's a valid point. Let's say that usually if you're working on code, you would use maybe Rstudio or maybe Visual Studio Code, and you would be working there, and there would also be a possibility to... Okay, so either way, you can see it on a program that integrates Git, or you have to use the terminal on the side to see that you're on the right branch. Nice. You also, when trying to pull the request, is this okay? Hopefully this answers your question. I'll see it if there is a follow-up question. And then, okay, so one comment in the chat is, when trying to pull request, I get this branch has conflicts, must be resolved. Is that the same error that you see that I have? And then if that is the case, we'll try to solve it now. Another question is how to create pull requests and merge the changes using the Git bash? So that's a very good question. After previous editions of this workshop, we didn't include it anymore here. So pull request, as James is mentioning, is a GitHub thing. The equivalent on Git bash is git merge. So maybe it's, James, if you're fine with finding some kind of tutorial that also mentions this. I think it goes a bit more technical into Git on the command line. It's very valuable to know how and that it is possible. But for some people that are not used on using command line, it drags us a bit too far because there can be mistakes, and then yeah.
Perhaps I can describe it conceptually.
Go
If
ahead.
you're okay with it.
Yeah.
So when you're using Git on the command line, you're directly manipulating your local tree. What I was talking about over the lunch break. When you're working in GitHub, you're using their web interface to manipulate their version of the tree. So a pull request is a way of saying, I want to do this merge, but not yet. When you press the merge button in your pull request, that's when it's literally running a git merge on GitHub's version of the tree.
Yeah, thanks. Yeah. I hope that's clear. When when we come to this concept of merging or pull requests, if you're lucky, it will work out fine. But yeah, it's not exceptional if you would get an error or it would say can't automatically merge. It's been a while since I've seen this, but let's see if we can fix it here live. Merge changes from readme into main. So now GitHub is not able to automatically merge them, so we will have to do something probably. And normally it should tell us where the problem is. So GitHub is now telling us this branch has conflicts that must be resolved, and the conflicting file more specifically is readme.md. We can fix this error either on the command line or we can use the web editor. This would be then the web editor. And now you can see the following behavior. And this is going to be always the case when there are some merging errors. What do you see? This kind of arrows equal to signs and these kind of errors. And what's also happening here, maybe more what could be the case is something else is written here, blah, blah, blah. This part underneath these symbols and above these symbols is part of the test branch, and underneath this equal to symbols and above the greater than symbols is part of, in this case, the main branch. Okay, do you see it? So test branch, main branch, and the things that are separated by these equal to signs are the things that we need to fix. So in this case, yeah, the error is not really obvious, but basically we want to replace nothing by the authors here. The other way around, sorry.
To elaborate on that a little bit, what's there is test branch removed the two author lines. So Git is saying, I don't know what you want, so you have to tell me what you actually want.
Yeah, nice, exactly. And we really need to like change it ourselves. So this means that we need to remove this line because we don't want it in the final result. We don't want these lines in the final results. So it asked us, do we want to keep it? In this case, let's say no. And then also remove this line. Basically, we're just removing everything here. So we're manually editing this file that had conflicts. And this seems okay for me. So I'm going to mark as resolved.
What Tu just said to Git there is, I want test branches version of this file exactly as it was.
Yeah. And if that is done, I can here tell GitHub that I'm fine with this final version. And now we're able to merge these changes into the main branch and hence merge the pull request.
So a slight comment on that. As there are many tools to help you working with Git, there are also many tools to help you working with merging. One of which is Meld, which I'll link to, which is a way of visually describing what Tu just did. It might be more intuitive for you.
Thanks. I reopened the slides. I hope that the exercise made sense, that it worked. If not, maybe it's time almost for having a break, and then we can have a look at it together. Final thing is deleting branches. Let's say that we have now created 2 branches, or at least I did. Let's have a look at how to delete them. It's rather straightforward, I would say, at least once you know where it is. So here in GitHub, you can click on 3 branches. So next to the main button, 3 branches, and then have an overview of all of the branches that are in this repository. Let's say that we want to delete the test branch, then we can just click the delete button here. And similarly, we can also remove new feature branch. Let me maybe show you in the comment line. Normally it's -d. So that would be the parameter that we need. So git branch -d, and then the name of the branch, let's say new feature. Enter, and then that branch has been deleted. So these are ways as to how to delete branches. I think now is an appropriate time to have a break. After the break, final important section is forking, and forking is also part of the GitHub terminology or logic, and this is going one step further in the collaborating process. But more on that later after the break, let's say.
Just so you know, you haven't been forgotten. There was a question about squashing and merging, and I'm struggling to find it now, but there was. We'll cover that after the course, I think, because it's fairly advanced topic.
Yeah. Yeah. Okay. I didn't see it even. Thanks.
I was wondering whether I should do it in voice, but I'll do it in chat because you might be taking a break. I mean, I'll answer in chat.
Hello again. So the next chapter that I would like to discuss is called forking. But before we start explaining about forking, I thought this would be an appropriate time to dive in a bit more into what GitHub has to offer when it comes to repositories. So what I did during the break was I pulled up a couple of examples from ourselves, and that I would like um, to show you what you can all do with GitHub. Because one of the fun fact questions which I normally ask is, well, Microsoft bought GitHub a while ago, I think in 2018, 17. And they paid a lot of money for it. And the question is then how much? Maybe you can do a guess in the chat without saying anything more. But basically what I'm trying to say with this is Microsoft bought it for quite a lot of money, and now they're developing GitHub continuously, and they constantly are changing the way how GitHub looks and all of the features that you can do with it. And yeah, it has become this what it is right now, but it's continuously changing, and like new features are maybe almost added every day. So a lot is changing in GitHub, and it's nice that you can do a lot of things with it. And one of the things that I wanted to show you is based on this repository. So this contains the course materials of another course that we give. Next to the code, which has a list of all of the folders and the files, of course, there is this tab called Issues. As this repository is open, anyone basically should be possible to create a new issue and then tells us something what he or she likes or does not like. For example, one of the issues is we do not have a cheat sheet in this repository. We should add it. And then I'm giving some suggestions, maybe matplotlib or one Python generally. And then Alex, our boss, has done this suggestion, for example. So we're having a conversation here. We can even like comments, and in the end, we can maybe change it in the code. And then if we now have a cheat sheet actually, so I can close it. We can say close issue. And then it's gone here in the issues tab. So imagine that you're collaborating on a project, you're having a new idea, you can raise a new issue in this issues tab, and then you can think about it together with the collaborators. You can label issues. You can also add an assignee. So for example, these three things are still things that I should do. And maybe some other thing is that there's already a pull request present here. So let's have a look at the pull requests. So this is issues then. Let's have a look at the pull requests. You can see that this one is still open. If I look at it, it is linked with an issue here, number 34. And James has created this pull request. So he's proposing some changes to the file, and now it's up to me whether I like them or not, and add them then afterwards. Moving on to actions, maybe not the first thing that you might think about of using, but at least I have an example of how we use it for another project. You can see there's a lot of possibilities, a lot of actions that you can add to a project. One of them is, maybe you're familiar with Docker containers, maybe you're not. Basically, what this action is going to do, it's a workflow. Every time that I push something to this repository, GitHub is going to test whether this new commit is working out fine. In this case, it's going to try to make a Docker container, and if it's fine, it's going to give me check, you're all set and good to go. Imagine that I've created something which doesn't make sense and we're not able to create a Docker container from it. It will give us an error and tell us like you need probably to change something in order for it to work. So actions, these are basically workflows and you can add a lot of them, and this is just one of the examples. Projects, and then I'm going to the next tab here because I don't have a repository that's also a project. What you could do is, I know that James is using it, for example, creating some kind of structure in your repository. So imagine that, again, you're working on a collaborative project and you set out guidelines as to we need to develop this and we need to develop this, and also a plot and also some documentation. And you can list all of these things here in a project and then move all of these separate items into a separate column when you started working on something, when it's in progress or when it's already done, something like that. So you can make some kind of collaborative strategy project by using these projects. Also here there are a bunch of tutorials online, so it's worth checking out. Maybe it's useful for one of your collaborative projects. And then I'm going back to...
I've just linked in the chat my a project that I'm actually working on at the moment.
Ah, nice. Can I open it?
Yeah, sure.
Yeah, Discord. Do you want to say something about it?
Not necessarily.
It's like a standard. Sorry.
Yeah, it's a if you're familiar with sort of project management, this would be a Kanban board. So you're tracking to-do items in the to-do column, things you're currently working on in the in-progress column, things that are waiting for other people in your team to check in the ready for review column, and things that you've decided are finished in the done column. And you can drag stuff back and forth between these columns. Say I'm going to start working on complex functions needing a loom are not nested. I can drag that into the in progress column.
Why is it not working? I'm not.
That's a title to and I think you probably don't have permissions.
Yeah, I can't do it now because I'm. Yeah, it would be crazy if I would be able to mess around with your project structure. Okay, sorry. No, and then yeah, you can see a lot of tags as well to make it a bit more visually interpretable. So these are the projects. Is the wiki also up to date? Is there something?
No, there shouldn't be anything. Yeah. Oh, actually, there is.
So here is the imagine. So this project is some software, and software is. It's always good to have some documentation about the software. You can write that down in the wiki page. And this is also, James, if I'm not wrong, is it the one that you can create a website from as well?
That's not this, no. So
anyway,
maybe to describe that, you can, so by default, you can have your name.github.io, and that you can have GitHub set that up as an actual website. We won't go into details on how you do that though, but it's fairly straightforward. If you have a search for GitHub static site hosting, something like that, you'll find it.
So that's a website, but I thought it's still possible to have a wiki web page as well.
Yes, yep, that's true.
Okay. Security, not really sure on this.
So that is, so if you, I gather some people here are familiar with Python. So the way you track, one of the ways you can track your dependencies in Python is with a requirements.txt. Things like that, GitHub will automatically scan and check for security alerts on. So say one of your dependency your dependencies has a security issue, it will come up here.
Maybe also not the first thing to worry about. Insights, we've shortly showed you already something in the gentle hands-on Python. It's quite nice to see, for example, here the contributors, which is just James and me. But you can see that we've did a major change, for example, here in June, July. Or otherwise, what did I else? Traffic network. So that's the tree again that we're looking at, but now it looks a bit more complex, at least when we go back in history. When we go back to June, July, you can see that here we started, at least James started with making a lot of branches, each branch for a specific feature, and then he started working on it. You can see it's developing over in time. Each commit is a dot here. And then every now and then, when we're happy about it, let's say, he's telling me, hey, Tuur, do you want to merge these branches in? And that's what I'm then doing. So that's why I'm always merging and James is always working. Okay, sorry, bad joke. That's a bit more what you all can do in a GitHub repository. Once again, if you want to remove a repository, settings, scroll all the way down, delete it.
If you press that Tuur, we can demonstrate. Press the delete this repository button.
Oh,
so it's not going to let you just do it because you may regret doing that. So it's going to make you type in the name of the repository before you can actually delete it. Just so you don't accidentally delete it.
All right. That being said, I think, or I hope that you have already an idea as to how you can collaborate on a project together with your colleagues. Just like James and I do on this project here. This is very easy to do, and it's also quite nice to do it in this way. However, you not always have access to the code of that repository. Imagine that you're seeing a very nice repository somewhere on GitHub and you want to use that for your own work, but you need to change some of these things. You'll most likely not be able to change anything right there. So what you could do is just clone that repository right in, but in your local file system, for example, but then still it has its limitations. Instead, what you could or should think about is creating a fork. And that's what I will explain now.
So, but maybe we should have a little bit of extra context. Fork is a way within the GitHub ecosystem of contributing to other projects.
Exactly. And that's what I'm trying to show you here in this picture. So up till now, we've seen this part right here up till your GitHub repository. There are also repositories online to which you cannot directly contribute. And for this specific reason, GitHub came up with a solution that's called forking. And when you fork a GitHub repository that is not yours, you're going to create your own version of it. So you fork that repository and then it becomes your GitHub repository. And if you do it in this way, then these two repositories are still connected with each other somehow. So imagine that the collaborative GitHub repository over here has changed. You can once again merge, like create a pull request and merge the changes that are that happened here in the GitHub repository back into your version. And then let's say that you have your forked GitHub repository. Of course, you can do exactly the same as what we've been doing before. You clone it into your computer and then So that's only done the first time. So downloading it into your local file system, and then do whatever changes to it that you like, add them to the staging area, commit them, and push them to your GitHub repository. Imagine that you've just created version 2 of this collaborative GitHub repository. You're super happy about it and you want everyone to know about it. You then still can create your pull request towards the collaborative GitHub repository. And then the other people, like the owners of that repository, can see your suggestions, and they might think about incorporating your changes as well. So this is a bit the philosophy. I'm seeing that someone is asking, well, typing a question in the chat, or at least something. While I wait, let me go to the next slide, which describes again what's called the fork and pull workflow. The question in the chat is, so branching is within a repository and forking is across repositories, if I understood correctly. Yes, yeah. So indeed, a branch is what you would make in your repository, at least a repository that you have contribution rights to, and forking is something which you would want to do from someone else. So this is what the general strategy would be if you think about the fork and pull workflow that I just tried to describe. I'm calling it here a central repository. So let's say someone else's repository. So you fork that one. It becomes your personal repository. Clone it locally. And then actually, instead of just working in the main branch, what you should do is create another branch. The question here is why. If someone can answer me that question, then you succeeded for the course, 10 on 10, 10 out of 10, A++. Create that branch, make some changes, whatever it might be, and then merge these changes into your development branch, and then make a pull request. With a new thing here also comes a new terminology. We now refer to the origin as your fork, as I described earlier. This is your GitHub repository. This is the origin, whereas the upstream, so if I refer to the upstream from now on, generally refers to the original repository that you have forked. So the repository of someone else that you have forked is the upstream. The one that is now your repository is your fork. And here comes an exercise. I was wondering if, since everything is going quite smooth today, yes, new branch, do not mess with the master one. That's a good reason. If you would keep everything in that new branch and create a pull request of your version of the repository towards the owner's repository, and keep everything in that branch, then they are still able to merge them in whatever other branch they would like to. So that creates more flexibility as well, actually. So as everything is going quite smooth, I was wondering, based on the slides that you have as well, whether you're able to figure out how forking works by yourself. So basically, it's just the one step that will be new, and then from there, it should be quite the same as all we did before. Let me quickly explain what the idea is. We will create a fork from a repository that's called fork-repository, part of the VIB bits. So you can find it by using the search bar there in GitHub. And then if you have forked it correctly, it should be now your own, and you can see that here by your name. Then the idea is that you can just change the master branch immediately, add your name to the participants list, and then request merge, if it's the, create a pull request, ask to merge your changes back into our fork repository. Does that make sense? The idea is now, at least for me, it seems like everything goes quite okay. I want to let you discover GitHub a bit by yourself. And then if you have problems, we can solve them together. And actually having problems is a better way of learning stuff than me just explaining you the obvious things. So you have the slides. Try to find out how this fork methodology works in GitHub and try to request us to make merges.
Could you keep that slide up for people?
Oh, whoa. Yeah, but yeah. Yes.
Thank you.
So not that many people have forked the repository. We can follow that. How many people follow the are forking? Is it clear what I'm trying to ask? Once you fork the repository, also try to edit the participants file and create a pull request and ask us to merge your changes into our original repository.
Just to be clear, don't fork tours, although you can.
It will just
fork
put us in a
VRB
bad...
bits one.
Sorry?
Yeah, fork the VRB bits one rather than tours version.
Yes.
It doesn't matter very much if you fork tours. There's one person who's forked yours.
Okay.
it'll just be slightly less obvious what to do when you come to doing a PR.
For us?
For them. Oh,
So
we have one pull request.
yes, shall I show it to everyone?
Sure.
Let me just open the browser here already and just leave it here for a second. And let other people just figure it out for a second first. Are you writing some messages, James? Nice.
Yeah.
Great.
Actually, maybe demonstrating the review process would be interesting too.
I will definitely. But I was waiting a second so people have
Sure.
the time to fork and edit and create a pull request. Maybe I will start with explaining how it goes myself first. I'm now deleting the fork repository so I can start from a clean sheet. Notice that I'm removing tmulder, so my own forked repository. Still have to give it my password. Check questions. To use pull requests exactly. So how to use pull request exactly. If it's okay, I will go over the solutions together. So the first thing that I will do is search for that repository. Let's say that first we're searching for this user VIB bits, which is the owner of that repository. I can find them by searching for the username. And then search for a repository. It was on top there. It's called fork repository. All right. Open that one. Seems interesting. Now I want to create a fork, so the only thing I need to do is just click this fork button. In this case, also asking me to which account we want to fork. And I will, of course, select my personal one. And what we see now, all right, after a while, now we have this symbol here, which represents the fork. And then followed by my name, and then the same name of that repository, which means that this is my repository now, so my version of the repository, and it's forked from the VIB bits. So we're referring to the original owner, the upstream, if we're using the correct terminology. Also here, this branch is even with VIB bits master. But if we're now going to change the participants file, let's say that I'm just adding a new version of myself. 10 December 2020. Okay. Added team elder participant. So I'm committing directly to the master branch these changes. I'm going back to the fork repository. And now we can see that this branch is one commit ahead of VIB master. So this is telling us that we are having a newer version of the VIB bits master. So what we can do is create a pull request. We can do it here or here. Let's say that we go from here. That's the easiest way, I guess. And now you can see that this first line that we've seen before is a bit more elaborate now, because now it also contains what is the base repository and what is what's called the head repository, so our repository in this case. So we can also here specify maybe a different branch that we need to merge, but in this case we're just keeping it clean like this. So we're going to merge branches master into branch master from tmelder version to the VIB bits version. And it's also telling us that it's able to merge. So no strange things going on here. So what I will do is create a pull request. This message line seems fine to me. Create pull requests. And then what you probably cannot see, but which I do see because I'm also owner of the VIB bits team, I can now merge these this pull request into the branch, into the original project, let's say. So merge pull request, confirm merge. And now in the code, nice, a lot of pull requests have gone through now. So now in the participants file, you can see that I'm again present here. Let's go to the review process of someone else. The first one was here, Yolene. You can see that James already gave some comments. James approved with the message, looks good, great work. Some more features even. James already approved. There's one pending reviewer, that's me. So, very nice. I was expecting this. Because we're all starting from the same repository and we're adding one line right at the end of the participants file, we're all trying to change the same line at the same time. So from this point, once I've merged one of these forks in, which was mine in this case, now all of the others are going to be a problem. because also your LAN has tried to edit the same line. So I will click on resolve changes, and now we can see again the same structure of error that GitHub is telling us. So here, yeah, the name of the branches are the same, so master and master, but basically it's telling us that this line is on exactly the same line as this line, and this one is already present, but this one is a new one, and GitHub doesn't know what it has to do with it. So we need to clear that out for GitHub. We want, in this case, both lines to be present, so what we will do, remove this line, remove this line, remove this line, and this looks fine as it is. We're going to mark that as resolved, and now we can say this is, we get an extra warning, but we can say now this is fine how it looks like this. We want to merge these changes in. And now I can say merge pull requests and confirm the merge again. It's always, it's almost a repetitive process now. And if we go back to the fork repository of VIB bits, now in the participants file, we also have your LAN present. Can you imagine now that if you fork a repository, let me go to my slides again. So this is what we did right now, all of these things. And this is the slide that I want to show you. Can you imagine that if we fork that repository, we edit something on the master branch, and we're creating a pull request that it's very prone to these error messages. It's going to create this, it's not going to be easy for the maintainer of that for that project to merge your changes into the master branch in the original code. Therefore, what's often a better choice is to create a branch as soon as you create a fork.
Also, the other thing to note, it's generally your, as in the author of the pull request, responsibility to correct merge conflicts, not the maintainers.
Because it can be a hell of a headache to merge in some of these, to merge in some things sometimes. So once again, an overview of the forking workflow, so fork and pull workflow. Fork a repository. Most likely you will clone it into your computer and work on the code from your computer. So clone it. Create a branch in which you will make changes right there. Do whatever you like with it. Edit, stage, commit, push. Once you're happy with it, you can create a pull request and ask for a merge to the original, to the owners of the original repository. Question, what if the upstream repository changed while you were working on your local repository and you want the upstream changes in your repository? And while I ask this question and wait for an answer in the chat, I'm also wondering if there are any other questions now. So this is basically all of the very important course materials. After this, we will talk a bit about the gitignore file, and then I'd like to ask also, are you interested in Git and Rstudio? So if you do a thumbs up on my question, interested in Git and Rstudio, I can also elaborate on that one. Usually a lot of people are interested in that. Is there any... Yeah. If you already now think about something that we still need to answer, also type it in the chat. And indeed, it's going to be Yolan. Yolan mentioned in the chat pull, so that's partially correct. But it's almost a nitty detail. What if the upstream repository changed? So that means the repository of the owners. So that one changed. The first thing that we will need to do is create a pull request so we can merge the changes from them into our forked repository. And then from there, we can do indeed git pull to have them also locally on our computer. And fork again is in this case not necessary. Let me show you maybe if I go to my repository. Remember that in the VIB bits fork repository, I just added Yolan as a participant. So now, James, you have merged everyone in? Almost everyone in. So you can see now that, great, thanks, James. So you can see now that this branch is 20 commits behind VIB bits master. So this means that the repository of the owners, VIB bits, has changed as opposed to our branch, as opposed to our forked repository. Sorry, all of these terms here. So what we now need to do is create a pull request. And from here, we can switch the order of the branches around. Dat gebeurt altijd, hè. So it's a matter of selecting the right repository at the right location. So what I now want to do is... good. From VIB bits fork repository, master branch, merge these changes into my repository, the base repository it's called here, tmelder fork repository. And do you get notified if there is a change in that repository? No, but as you can see here, there is indeed an indication of it, like 23 commits behind the master one. So if we want to work in a group, let's say work in the same codes, which one is better, use branching or forking? In the same group, I would say branching, because it would be the same situation as I showed you with the Python materials. So James and I are both part of this organization VIB Bits, and so we can work on the same projects with the same authorization. Yeah, permissions. But you can also set that for a specific repository that you own, for example. You can give someone specifically permissions to write in that file. Okay, I'm going to give another example. Reproducibility case. So we have this repository, private repository, part of the VIB bits team, but I can change things to that repository because I'm part of that team. And in settings, you can go to manage access. And here you can add someone's name and then give that person specific permissions. For example, Richard is someone that's not part of our team, but this project does relate to his, it's part of his work as well. So he can, for this specific project, also, in this case, write to this repository. So you can give specific people specific rights, even though this repository is, for example, private for only VIB-Bits team members. Does that make sense? Hopefully. But that was a very long deviation from is it branching or forking the most interesting. Generally, as James mentions, setting the right permissions. Once that is done, it's easier to just create branches.
EW, that is actually the typical that's actually the typical workflow, because when you fork, you're usually working on a specific, say, bug fix or feature. So you'll fork it, do your fix in a branch, pull request, delete.
Another comment, how...
They're not usually long-lived. Sorry, too.
No, thanks. How are open source projects, libraries, modules managed? Forking with limited access to permissions. So basically, you can have open source projects. They live openly, freely available on GitHub. You do not have any writing access, although maybe you're part of the team that manages it. But let's say that you're not part of that members team. The code is open available, and what you can do is then create a fork, and then it becomes your repository, and then you can do whatever with it that you like. So that allows us to use that code ourselves while not messing up the code of the owners. Is FastQC on there? I don't know. I'm trying to find an example. Let's say that this
These
person...
are forks, so if you click on the Insights Forks button, you'll get to the original.
Where?
If you go back. So select any one of them. These are forks. So click any one of these repositories.
Those are forks. Okay.
Then Insights Forks, and you'll get the original.
All right, here's the original one. All right, so let's say that this is the original open source FastQC module. Then from here, like all of the 37 other people have done, we can create our own fork from that. So we cannot change anything here. We cannot change the README file. Remember that for us there was this pencil button. We cannot change that, for example. So what we can do is make a fork, make it our own. It's going to take a second. And now we are able to change that README file, for example. So now we can change this code. So this is how you can collaborate on an open source project, for example. All right, thanks. Further reading materials brings us to Git ignore. Very shortly, as I mentioned before, let's just dive into it. GitHub is not your next data storage file system, right? So actually there is a file size limit in GitHub, and that is set to 100 megabytes. So arguably it's still a lot, but as an unwritten rule, it's not supposed to contain data. You could add some CSV files or something like that, but like don't put like big data in GitHub. But sometimes, as I mentioned also before, it's just makes sense that your data is in the same folder as the project that you're version controlling, right? So you might have this project that contains data, and then the data is in there. What can you do to not upload that data is using this gitignore file. And what it contains is a list of expressions which define the files that do not need to be tracked. So imagine that you have a project that looks like this. So you have a folder that contains a folder called data that contains a fastq file and a CSV file. And besides that, we also have a bunch of files. Amongst many others are, for example, the IPY and B checkpoints or the R history files. These are files that are part of a project in R or maybe a Jupyter Notebook project. And generally, they're not supposed to be uploaded to GitHub either. So here's a list of expressions that you can use to ignore some of these files, part of your project, but not want to be uploaded to GitHub. So ignore a file or a folder if, for example, you define the following line in that gitignore file: data folder /r1.fastqc. So that will refer to this file being ignored. Or if you want to ignore all of the files as part of that data folder, you can just write down the line data /. So that refers to a folder. You could also say .ipy and b checkpoints explicitly, and then it's going to ignore this file. So you can name all of the files explicitly, but you can also use a wildcard. This is this asterisk. And then all of the CSV files in this project folder are then ignored. Imagine that you want to ignore all of the CSV files except for one, dataset.csv, for example. Right after your asterisk, you can then write an exclamation mark followed by the name of that file that you do not want to ignore. So that needs to be uploaded to GitHub, for example. And then, of course, you can have documentation lines with the hashtag. Now you can write these gitignore files yourself. And if we would look at one of my examples again, let's go to Nextflow course. This is a gitignore file. And this one I wrote myself. Basically, it's going to ignore the folder docs and presentations. It's going to ignore Jupyter Notebook intermediate checkpoints. It's going to ignore the data folder and all of its files except for this one download data.sh file. Ignore the results folder, and then ignore all of the files that contain any of these extensions. So fastq, fastqc, gzip, gtf files, fosta files, sum files, bum files, etc. So I hope that makes sense. You can create your own gitignore files, but it's also possible to choose one of GitHub's gitignore files. And imagine that we create a new repository. Remember that we can add a gitignore file here as well. So if we select that, there are a bunch of templates available depending on in which language your project is mainly written, for example. So say that it is in Python. yeah, git ignore Python. Let me quickly create that repository to show you how that would look like. I'm opening the git ignore file that has been created. And now you can see, yeah, all of these files that are often part of a Python project, files and folders that should be ignored when you upload, when you push changes locally to GitHub. Let's see. I think, for example, also here, if you use Jupyter notebooks, these IPy and B checkpoints are also ignored. Yeah, but a bunch of other files. I usually start from the basics because then I have full control over what is being ignored and what not. It's just how I work. Maybe these standardized files do make sense for you though. You have also ones for, let's go back to the slides, R, maybe also Ruby, Java, Perl, C++, depending on what you're interested in. They can also, of course, be added later on in the repository as well. All right, that already brings us with GitHub and Rstudio. Let me first check if there are any questions. Any questions up till now? Shall we have a small break before we talk about Rstudio? Yeah. So Squash question will be right at the end, if that's okay. Is it okay if we have a 15-minute break, or do we want to continue?
Good for me.
Okay. Break of 15 minutes, so let's say 3:55. I feel so German if I go almost up till the minutes. 3:55 p.m. If you're bored, James changed the fork repository. So you can try to merge the changes back into your fork repository. And then maybe you can also try to make another clone of it locally, try some changes over there, make a branch maybe. Just test whatever that you like to test. If you have any problems, now is actually a great time that we can help you with it. Hmm. 3:55. We're starting on time again. And James pointed out that there was a question in the YouTube chat, which I would like to bring up here for everyone. So what was asked in the GitHub chat, hopefully I answer it correctly, relates to the fact that if you want to clone a repository, there are actually several ways as to how to do it. So if you click on this green code button, you will see that we've copied now the HTTPS link, which is a reference to the GitHub folder, and is then going to clone the repository in your local file system, let's say. Another way how to do it is with SSH, but then, as we mentioned in the morning, you will need to get this SSH key set. We can still help you with that, let's say after the course, if you're interested in that. But there is another possibility, and this is maybe confusing, or you should pay attention to it. You can also download as a zip file here. And what will happen is, why don't we just do it? So we download it as a zip file. I'm opening my file system here, opening the downloads section. You won't be able to see it. So it's a zip file, and if you extract it, it's not going to be a Git repository. Why? Because you're just downloading all of the contents of that repository, but you're not downloading it as a GitHub repository. So as such, it will be not version controlled. It will be only the files and nothing else. So there is no .git folder, which then contains all of the information of this repository. So there is a difference between cloning and downloading. Hope that makes sense. And then, also to mention, if you're lost with any of the things that we covered today, don't be shy to contact us, like maybe next week or later on. I'm here to help anyone with any questions, and I'd be happy to do it as well. And James is, he's not paid to do that, but he's always happy to help as well, of course. Right. Rstudio, that's what we were going to talk about. Let's open up the slides first. Here we go. So here is a list of the different situations that you might find yourself in. And let's go over them one by one. It is possible that you have a folder on your computer which is version controlled. And now at this specific point, you want to start analyzing some data in it in Rstudio. So you have a version control project that you now want to integrate in Rstudio. That's situation one. Second situation might be that you have a repository of a colleague of yours on GitHub, and you just want to incorporate that project in Rstudio. This is the first thing that we will explain here in this section. And then the second thing that we will explain is the last situation here. That could be that you already have an Rstudio project, which is probably very relatable for you. So you already have an Rstudio project, and now you want to start thinking about version controlling. So now you want to use Git on top of this Rstudio project. 3 different situations, and the last 2 ones are the most relatable ones. First, this second situation here, which is the easiest to integrate, and then later this example as well. So if we want to integrate a version controlled project in Rstudio, we can do that, and I'm going to show you immediately. So this is what the steps that you would follow, and maybe I will quickly scroll through the last slide of this section, which is the full tutorial on our website. Okay, so you can follow along. You can also do the same things as I do. If it's going too fast, you can have a look on our website and then see all of the things that I did right there, even in more detail actually. So imagine that we're starting a new project in Rstudio. And I'm opening Rstudio right now. Okay, it looks like this, let's say. I'll keep an eye on the chat if it is too small or it's not clear. If we want to start a new project, we click on File and then New Project, and then this kind of tab opens up. And from this point, we have several options. The one that we're interested in right now is choosing version control. And you can see that there are two options here. Git relates to what we've been using up so far, so Git version control system. There is an alternative, as I mentioned before as well. It's called Subversion, which we did not cover today. But just to mention that there is an alternative to Git, we're of course interested in Git. And then we need to give it some information, starting with the repository URL. So let's find that one. And for this example, I'm going to use the repository that we created this morning mainly, which is called Introduction GitHub December. And it's not a coincidence now you see that these plot files are script files. So the URL is the one over here. So the one from the clone, the code green button. And then we'll copy paste that in the repository URL, and then immediately we're given a project directory name. I will leave it like that. I will create the project as part of the documents folder, for example, and create that project. So that's the beginning. It already exists over there. Yeah, this is because the folder already exists here.
You can delete it from that interface. That'll look good.
Actually, I can, yeah. Okay, so now the folder doesn't exist anymore. Thanks, James. Let's create a new project, version control, Git, copy paste the link. I want it to be part of my home folder here, and then create project. And it went very fast, but maybe you've seen that Git was cloning some stuff. And now we have this repository, this project in our file system. And what you can also see is now here on my right upper corner side, we have an extra tab that's called Git now. And this is the feature that we will use when it comes to Git. Let's make an example here. Say that we make some changes in plot 1. This is a subtitle. All right, looks nice. Control S, we've saved it. Now this Git feature, this Git tab is telling us that files have been changed. So this is a list of all of the files that have been changed, and the status here gives us an indication of what kind of modifications have happened. So the question mark means that this file is not tracked yet. And the M, for example, means that this file has been modified. Imagine that we want to put all of these changes in the staging area. Then the only thing we have to do here is click on stage. That is still fairly easy. After staging to the staging area, we now have to commit. So that's this button here, commit. And now there's a new tab that opens that gives us basically an overview of all of the changes that have happened. So Rstudio made a git ignore file by default the moment that you introduced this project here in Rstudio. So this git ignore file contains these 4 lines. And these are all related to the Rstudio logic. Rstudio always also has an R project folder, which we also don't want to include. And then the file that we modified ourselves now also tells us that there is a subtitle here. So this line has changed. All of these files are staged. And now here on the right-hand side, we have to write a commit message. Let's say initial commit in Rstudio and subtitle plot 2, plot 1. And then we can say commit. I'm going over the routine usage right now, right? Then Rstudio is telling us that it did this commit, so it's the same message that we would get from the terminal. We can close that, we can close this, or we can click on push if we already want to push to GitHub. But let's say that we close this one. Let's add another in title plot 2. Let's say that we add subtitle. Nice. So you see, as soon as I changed this file and saved it locally, Git is telling us that there has been some modifications to a file. Stage them, commit them, adding a commit message, for example, added subtitle, click on commit, close, and now we can, it also tells us your branch is ahead of origin main, so the one on GitHub, by 2 commits. And now we can select push to update our GitHub repository. Takes a second, and now it's done. So we can close this, and we can go to GitHub, refresh the browser here, and now we see that there are some new changes. Sorry, I've been mistaken with the R project file. It's not part of the git ignore file. It's just there now in GitHub as well. So now the two are linked with each other, and any change at any point that you make here will be listed in the Git tab here. And then from here we can use the same modules that we explained during the day today, also in Rstudio. Diff is something that we didn't discuss. Diff is very useful actually. What it can do is it will compare files with each other, for example. And then you can have an idea of what changes have been made so far. Let's see. Yeah. So also here in this new tab, you can also have an overview of the different branches that are here, the changes that were made in that specific commit, the commit message, of course, so who did it, and an identity, so the hash of that commit. I hope you recognize all of the things that we described earlier. Pull. is going to pull changes from GitHub to our repository here. Have an overview of the history. It's going to open the same thing actually. What else can we do? We can
maybe demo a revert. That's not a bad idea. So say you realize a change you've made in the past was wrong. How do I undo it? This is one way.
I'm not sure how it works on. I don't use Rstudio that much actually.
Okay. All right. Never mind.
So maybe if we pull up, I would have to search it. Guess that. Yeah.
Oh, that's just undoing.
Yeah.
Okay. Fine. Whatever. That's
not a
not as
real
useful.
revert. So you can undo changes by clicking on reverts. You can also, if you create a new file, let's say in R script, is it with double N? Unnecessary file. Blah, blah. All right. Now you can say ignore. And then this file will be added to the git ignore file. So say that you don't want this file to be pushed to GitHub, you can add it to the git ignore file as well.
Make sure you don't stage it, though, of course.
Yeah, then you have to unstage it. And now you can see that we modified the git ignore file because you can see that we added blah blah.r as a file there. Okay, moving on. You can also see the branch section here. If it would be smaller like this, it might look like this. If you make it larger, then you can see that this relates to the branches. You can have, for example, the new feature branch. I'm going to mess up all of these things, or you can create a new branch here. Let's say add plot. The remote is the origin, yes. Sync, yes. So that you can leave that on default. And now you can see that we're in a new branch. And now if we add a new plot, we can work with branches in this way. So you can add changes here, then switch branch to the main branch, and then add some other changes over here in the main branch, and then have these separate versions like that over there. And then I should also show you how we can, going back to the slides, initiate a version controlling on an existing Rstudio project. I'm not sure if I have one ready that is not version controlled. These ones are not. So basically what you would do, okay. It already existed. I'm sorry, I have to make a new project that is not version controlled and which doesn't exist yet on my computer. Oh man, I'm coming
Test
up.
_2 real 1 final.
Yeah, great, thanks. Final, that's the name. So I'm creating this new project. Imagine that this project already lives on your computer, right? And it contains a bunch of very useful scripts. And now we learned about Git and GitHub. And now we want to start using version controlling on this project. What do we have to do now? And the steps are actually given here in the slides as well. So that's hopefully making it easier for you to also do it again. So let's see. We're going to Tools, and then click on Version Control, and then Project Setup. And then we have to go in the tab Git as VN, and then use Git as our version control system. It's asking, do you want to initialize a new Git repository on this project? If we click yes, what's going to happen? You need to restart. Okay, great. Basically, under the hood, what's happening? The command git init has been launched on this project. And normally it's just initializing Git on this project, but for Rstudio, it's also similar as I described in the first example. It's also opening a git ignore file, and it's creating a git ignore file and the R project. No, it was already there, sorry. It's also creating a git ignore file. So now it's, this is a great example. So now this is version controlled. Let's say that we stage these changes, commit, initial commit. Let's not make it too difficult. Close. What do we want to do now? Nice. It's not even possible. Push. Why is it not possible? Because we locally initiated a Git repository on this project, but we cannot push it to GitHub because it doesn't exist on GitHub yet. So what we need to do is go to GitHub, and we'll have to create a new repository. So now I'll do it on the top right, new repository. We can name it whatever we like test final Rstudio final. It can be public, it can be private, it doesn't matter, but it's important that it's an empty repository. And now we can copy paste the link. And what we now have to do, go to Rstudio. You can see that it's called the master branch by default. Already on master. Where do you have to put it again? Oh, jongens toch. Can I do it like this? Nee.
That looked origin. What you're doing, new branch looked right because it had an origin field. So Tur is trying to work out how you set an origin.
Add a remote.
Oh, there we go.
Yeah, okay. Sorry. So what we need to do is add this remote. So we have to link it to GitHub, remote name.
That would usually be origin.
Yeah. Oh man. Yeah. And the branch name is then master.
Looks like you can't just set an origin. Or maybe you can and it's done. Can you push now? No.
Nee. Oh man, I think they've changed it or something. Branch name master. Add remotes. Remote name is origin. Create, and then would you like to check out that branch or override it?
Override. Maybe that's the right thing.
No, we want to check out this branch.
Okay.
Okay, no. I'll have to update the materials again.
You don't need to keep on editing that remote. It's already there. Yeah, that's doing the right thing.
That looks a bit better. Wow, very bumpy. This has been a while, I'm sorry. At least if we now refresh, let's see if it worked. Okay, at least this is good. Initializing Git repository is a one-time effort. Once it's set, once you have the Git tab over here, it's easier to start using it, of course. Now you can just like create an R script, add something, change, and then start using it. I'm opening the chat to see what questions might arise now. So at this point, unfortunately, I did not include any exercises. If you have any questions, type them in the chat. I'll be happy to answer them. But I don't have any exercises here specifically. So it's a bit up to you now to test these things out. Other stuff that you might find interesting is a further reading on issues, pull requests. Yeah. These things I already showed, the settings, the project board, the wiki.
Have a look at the Git book.
The Git book is indeed a nice reference. This last link in the further reading is also where did it open? A cool thing, it contains like exercises that you can do in in this graphical way. So remember James drew this tree. These are basically exercises that make the use of Git a bit more visual, so you can see what's happening.
Whoa, I didn't know about that. That's fantastic.
Yeah, it's pretty cool actually. So this would be something interesting to check out later on. And that's it. That's all I have.
And we're going to explain squashing, which also means we've got to explain interactive rebasing. So this will be fun. So if you want to stick around, I'm going to do some squashing and interactive rebasing.
It's okay, James, if I wait one more second. Any other questions?
Yeah, I don't want to start right now. Anyway.
Because squashing is really it's next level, no?
Yeah.
Well, I mean it's Okay, so I hope that you enjoyed the workshop today. I hope you learned a lot, and at least it was useful. Once again, you all have my email address, so if you're starting to collaborate on projects, you have questions still as to how you need to set up stuff, then we're always happy to help to figure it out together with you. And other than that, thank you very much for being here, for also participating from the beginning to the end. That was really nice. And yeah, maybe hopefully see you another time in real life then. And feel free to stick around to see us struggle with rebasing and squashing and stuff like that. And thanks for the comments in the chat as well. All right, James.
Have a great evening, everyone.
Interesting. Nice.
If you're still around, I assume you're interested in finding out about rebasing and squashing.
Whee. Did you have a think about it, James? How to address it?
I just crashed. I just got back. Okay. All right, we're back. I have my camera going if you want to switch me on.
Yeah. I don't see your camera.
I don't have my camera on anymore, of course. All right, there we go. Chat.
Sure.
Actually, I don't need push to talk. All right. So say we're in this situation where we have a common history. I'm going to full screen my camera so I can see what it's like. We have a common history. Then here we branched. We called it new branch, and we've got 3 commits on our new branch. In the meantime, master has a new commit on it too. So there's a few things that can happen. Say we want the changes that are in this master. One way would be to merge master into our branch. What would that look like? You'd have a new commit called a merge commit here. Then new branch would point to this branch, can't spell, would point to this merge command. So that's one thing that happened. Another thing you can do is rebase. Wrong direction. And what was here just makes the history look like we started off with a branch at the current head of master. Ignoring this for now. So a rebase just says pretend as if I had branched at the head of where I'm rebasing from. So when you are doing a pull request on GitHub, you have these 3 options. You merge, you rebase and merge. That would be exactly this. And then master points at the end of your series of commits, or you squash and merge. What does that look like? So you've got your common history. And then we've got this branch here. A squash and merge says squash all of these 3 commits into one and put them here. Does that make sense? So why would you want to do that? So this commit might have been useful. Do useful thing. This might have been fix typo, and this might have been something other silly change. These pollute our history. They make looking at the history less useful. There's no reason to have these as separate commits. So if we squash them into one, it looks like as if we've done a useful thing in just a single commit. So that's why we want to squash. And unfortunately, the GitHub user interface only allows us to squash all our commits into a single commit when we press that button. Maybe that's not what we want to do. Maybe we had another useful thing that is useful as a separate commit here. Useful commit. So what we actually want this to look like is two commits. And the way you do that is with an interactive rebase. So you do that on your local machine, and you say, squash these into a single commit and keep this as a separate one. So now our branch would look like that when we merge it into, and then you can just do a rebase merge into master. What would happen if there were conflicts with the three commits that were squashed? That can't happen by definition because you can't conflict with your own history, if I understand your question correctly. So you're asking, let me go back. What if I'm squashing these commits, what if I conflict with this? That just can't happen. You can conflict with this. So if you say squash and rebase, you can have conflicts with master there. But GitHub will tell you before you just won't make the button available if you have conflicts. If you conflict like this, you'll also conflict when you're squashed. Hopefully that answers your question, Ganesh. So squashing doesn't make any changes in itself. Although when you do an interactive rebase to say squash, there are a bunch of options you can do. Squashing is one of them. So maybe it's a bit out of scope to show the interface, but there's a bunch of things you can do. So you can pick a commit. Let's just leave it as it is. You can squash, which means squash that into that. You can drop, which means just get rid of it completely. Squashing always happens within the same branch line. Yes. Yes.
Mm.
This I should label as merge. All right, so that summarizes squashing and, well, different techniques for merging code.
I think that was a good explanation.
And everyone's out of the chat.
Yeah, in Discord, but I imagine that people are still following on YouTube. Because if I switch now to the course chat, you can't see.
Brilliant.
Nice.
I hope you had fun, Ganesh. I'll stop sharing my video.
All right. So that's it. And I stop streaming to YouTube as well.
Have a great evening.